We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, Hacker Frogs. It's me, the Shy Hat. And we're doing HackerFrogs AfterSchool today. We're doing HackerFrogs free hacking. We're hacking all the things. So let's talk about what we're doing today. And on YouTube, David Nelson. Hello, nice to see you here, and welcome to the stream. We typically do 4 topics on each one of these live streams, and today is Friday, so we're doing a variety of different things. It's December 19th, and the first thing we're going to be doing today is we're going to be doing Advent of Cyber. So Advent of Cyber is a Christmas event that is that they do over at TryHackMe every year. It goes from December 1st until December 24th, and we're going to be covering days 18 and 19 as the first topic of today's stream. In the second topic, we're going to be doing HackerFrogs AfterSchool. So this is our education program, and we're currently doing our network hacking course. We're learning about how to do network CTF challenges and how to hack on the network. In this session, we're going to be learning about more Linux privilege escalation techniques. So these are ways to elevate your privileges from a regular user to a super user. So that's going to be the second hour of today's stream. Please look forward to that. And in the third hour of today's stream, we're going to be doing some cryptography challenges. So this is going to be slightly different. We're not doing cryptography challenges at RingZeroCTF.com, but instead we're going to be doing the cryptography challenges over at hackmyvm.com. So this is a different CTF platform, but we're still doing cryptography challenges, and that's going to be in the third hour of today's stream. In the fourth hour of today's stream, in the fourth and fifth hour of today's stream, rather, we're going to be doing cloud hacking. So cloud hacking is a very sought after set of skills for anybody who does cloud hacking, well, cloud security stuff in general, or people who also do web app security, because a lot of web apps have cloud integration baked into them. So we're going to be going to PwnedLabs.io to do their free cloud hacking labs over there, and that's going to be the last topic of this live stream. So without further ado, let's go ahead and jump into the first topic, and that's going to be Advent of Cyber over at TryHackMe.com. So this is a platform where you can do these exercises completely for free, and let me go ahead and get you the link. So if you are logged into TryHackMe.com, you can access all the Advent of Cyber stuff over at this link over here. And we're going to be doing days 18 and 19 to start off today's stream. All right, so I think what we can do is we can play a little bit of music while we do this as well. And let me go ahead and pull up my music list. How about some of this? As usual, if you find any of the music is too loud or too distracting, let me know, and I'll try to do something about it. Okay, so let's do my YouTube intro for this particular room. All right, everybody, this is day number 18 from the TryHackMe Advent of Cyber event for 2025. So this room is called Obfuscation: The Eggshell File, and this is the link over here. So after you've joined the room, we want to go down to task number 1 and catch up with the story. So there's an ongoing storyline that goes along with each one of these rooms. Let's see if we can talk a little bit about this before we start. So Wareville has not felt right since the wormhole appeared. Everybody in the TBFC is on high alert. Systems are going haywire, dashboards are spiking, and SOC alerts have been firing non-stop. Amid the chaos, McSkitty keeps her focus on a particular alert that caught her interest, an email posing as North Pole HR. It's littered with carrot emojis, but the weird thing is this. There is no North Pole Human Resources Department. TBFC's HR is at the South Pole. Digging further, she found a tiny PowerShell file from that email that was downloaded. Among the code are random strings of characters, all gibberish, nothing readable at a glance. McSkitty knows that malicious actors often hide code and data using a technique called obfuscation. But what is it? Brolin, thank you very much for subscribing on YouTube. Thank you. A technique called obfuscation. But what is it really? And how can we decipher it? So our learning objectives for today are: learn about obfuscation, why and where it is used, learn the difference between encoding, encryption, and obfuscation, learn about obfuscation and the common techniques, and use CyberChef to recover plain text safely. So in this exercise, we need to do the following. Do we need to start a VM today? Yes. Is there a split screen available? Yes. So to start up this exercise, we need to click on this button over here, labeled Start Machine. Click on that, and then the virtual machine that we're going to be using for today's exercise is going to start loading up. So in the meantime, while we wait for it to load, we can get some other stuff done as well. So we answered this question over here. Start the target machine and continue with the next task. We'll click on the checkbox. Okay, and then we'll move on to task number 2. Understanding the gibberish. Obfuscation is the practice of making data hard to read and analyze. Attackers use it to evade basic detection and delay investigations. So let us say a security tool will automatically block any file that contains the word "the bandit yeti." To evade this, the attackers can use a simple cipher technique called ROT1 to hide the string. ROT1 is a cipher technique that shifts each letter forward by 1 in the alphabet. The letter A becomes the letter B, the letter B becomes the letter C, and so on. Using this cipher, "carat coins go burr" becomes this message over here. So this can be further complicated by using ROT13, which moves the characters forward by 13 spaces. So where is obfuscation in the real world? So far we've kept it simple. In the real world, you'll encounter a wider range of techniques. One slightly more complicated technique would be to utilize XOR. Each character is represented as a byte, and each byte is combined with the key using the XOR mathematical operation. No need to go into the details as how it works. The only thing you need to know is that this operation changes the bytes into different bytes, which sometimes makes the resulting text end up with uncommon symbols or non-readable characters. Obfuscating with XOR is not something that can be easily done manually, but thankfully there are tools available that can help us with this. One such widely used tool is called CyberChef. Let's try obfuscating a string using XOR by following the steps below. So open CyberChef by visiting this link in your browser. So we've got CyberChef. This is a pretty common tool. Let me pull it up. Okay, and what do they want us to do? Okay, at the top right you will see the input box. This is where you will paste the text you want to change or obfuscate. In our case, use carat supremacy. Okay, so we'll just copy this, and then we will go over to CyberChef, and in CyberChef there's an input window here. We can paste the message in here, and then we'll go back. What do they want us to do? In the left pane under Operations, search for XOR and drag it into the middle under Recipe. This tells CyberChef to apply the technique to your input text. And each operation has settings you can adjust. In our case, we'll set the key to A. Make sure that the drop-down next to key is set to hex. Okay, so we'll go over to CyberChef. We'll search for XOR. And then we'll grab XOR here and drag it into the recipe box. Okay, so from here, we're gonna set a key for XOR, which is the letter A, and we'll make sure that this is in hex. The key is in hex. And from here, we see that the input carat supremacy has been transformed by the XOR operation into this output over here. Okay, so do they want us to do anything else? The obfuscated result should automatically appear in the output section. If it doesn't, click bake at the bottom of the screen. As you can see, the string carat supremacy now becomes this string over here. Detecting patterns. The good thing about well-known obfuscation techniques is that it's easy to reverse once you figure out which technique was used. You can use these visual clues to guess the obfuscation techniques used. So ROT1. Common words look one letter off, spaces stay the same, easy to detect. Shulk or Max, hello, nice to see you here. What is up? Let's give you a fun Hack the Planet. Here you go. We're just doing Advent of Cyber day number 18 right now, and then afterwards we'll be doing day number 19. Rot 13. Look for 3-letter words. Common ones like the becomes gur, and becomes knack. Spaces stay the same. Base 64. Long strings containing mostly alphanumeric characters, such as A to Z, uppercase and lowercase, and the digits from 0 to 9, sometimes with a plus or a slash, often ending in 1 equal signs or 2 equal signs. So XOR is a bit more tricky. Look for random symbols that stay the same length as the original. If a short secret was used, you may notice a tiny repeat every few characters. Once you have a guess on what cipher was used, you can go back to CyberChef, but this time use an operation that does the reverse effect. For example, to deobfuscate base 64, you use from base 64 instead of to base 64. Okay, so I'll give you a little example here. So let's say that we've got a message. So the message is going to be something like HackerFrogs, like and subscribe. And we want to obfuscate this by using the base 64 technique. Okay, the Black Cyber Duck says, what is this all about? Are we doing cryptography? We're doing obfuscation, which is a little bit cryptography, a little bit of encoding stuff. And you can find it over at TryHackMe, which is a pretty popular website. We're currently doing this module over here. It's part of a Christmas event. Okay, so if we want to encode this using base 64, we would run a command like this, which turns it into a base 64 encoded string. So if we copy this, then we go over to CyberChef. So say we have CyberChef over here, and we will paste in our string in the input, and we want to transform this back into plain text. So we'll get from base 64, and we will apply it to the string by dragging this into the recipe box. So we get the original message back. HackerFrogs, like and subscribe. Black Girl for Sex says, just wanted to say I appreciate your content, helps me so much. No worries, no worries. I'm here to help people get into InfoSec and to teach people how to do this stuff. So welcome to the stream. Hey. All right, let's go back to TryHackMe. Okay. So where were we? Okay, unfamiliar patterns. Not sure what you're looking at? It's fine. Even if you don't have an idea of what cipher was used, it's easy enough to keep on trying different operations just to see if the text becomes readable. CyberChef also includes an operation called magic that automatically guesses and tries common decoders for you. To use it, just add the magic operation and look at the results. It will display multiple results, and it's up to you to check which one ends up making sense. You can even check the intensive mode, which tests more for more possibilities before giving up. Okay, so we'll demonstrate this over here. So we'll just get rid of the from base 64 recipe, and we'll just try using magic. So we've got the magic method, which is just a bunch of different tests. Okay, so when you apply magic to your input, it'll give you a bunch of different results. So it tries to find readable strings, and it'll put those results near the top of the output. So for example, HackerFrogs like and subscribe, and in this case it was able to get it done. It also tells you what operation was used to get the result. So the Black Cyberduck says, how did you know that it was using base 64? I mean, this is something that we did ourselves. This was just an example that we did. We encoded it into base 64, and then we got the result back. Okay, let's go back. Of course, this won't catch anything, especially custom XOR keys or unusual layers. So use it as a hint to help you in figuring out. For example, one of the questions below cannot be fully solved with the magic operation alone. So we got layered obfuscation. To make obfuscation harder, threat actors would often combine multiple techniques, almost like a layered approach. For example, a script that threat actors want hidden could be compressed with gzip, XORed with an X key, and then finally Base85 encoded, and this will produce the obfuscated string this. Okay, so let's grab the string, and let's put it into CyberChef. So we'll grab this, we will get rid of the magic operation here. In the input, we will paste in the string we just got, and let's see what they want us to do. So to reverse this kind of layered obfuscation, apply the operations in the opposite order. So Base85 decode, XOR with X, and then decompress gzip. The screenshot below shows how to chain these operations to recover the original content. Okay, so we can do this ourselves. So we'll go over to CyberChef. We will Base85 decode, so it's from Base85. We'll grab that operation and we will apply it first. Okay, so we see after the first operation we get this output over here, and the next step is to do the XOR operation. So XOR, we will grab XOR and we'll paste it just underneath the first recipe, which is Base85. So we're going to supply a key X, and I think, let's see, XORed with the X key and then Base85 encoded, X key in hex, okay, and then they want us to do G unzip, so decompress, okay. So in here, key X in hexadecimal, great, and then we get this output here, and then finally what we want to do is we want to get the G unzip. Okay, G unzip or gunzip, we're just going to paste it in here. Okay, so we've got, we have actual readable message here. So it looks like some sort of command output. Okay, so we've managed to decrypt or deobfuscate the message here. Alright, so unwrapping the Easter egg. So luckily, McSkitty detected something fishy in the email we received. She extracted a PowerShell script from the PDF and put it on an isolated VM to figure out what it's doing. There is some obfuscation in the script. Can you help her understand what it is? So open santastealer.ps1, located in the VM's desktop in Visual Studio, by double-clicking on it, and then navigate to the Start Here section of the script. Follow the instructions in the code's comments and then save. Then run the script from the PowerShell terminal to get your first flag. To open PowerShell, click Start, type PowerShell, and then press Enter. Okay, so we'll demonstrate how to do this right now. So we've got our machine over here. Let me drag it out to make it big. Okay, so 4Vibe says it's the most common encoding option in CTFs. So yeah, you're going to see a lot of Base85 encoding in CTF exercises. You're also going to see a lot of ROT13 or like Caesar Cipher as well. Okay, so we're just going to double click on this icon here, Santa Stealer, and this is going to open up the script in our text editor. Okay, so this is Visual Studio Code. And they want us to start here. So start here, part 1, deobfuscation. So step 1, deobfuscate the string present in the C2B64 variable, then run the script to get the flag. So we see here there's the C2B64 variable over here, so it is this. Let me copy this. We're supposed to deobfuscate this. So because it says B64, we suspect that this has been Base85 encoded. So let me copy it, and I can give it to everybody in chat as well. So what we can do with this is we can go over to CyberChef, and in CyberChef we're just going to get rid of all the other operations, and we're going to get rid of our previous input. So in its place we will paste in the stuff we just copied, and then we will get the Base85 decode operation. So it's from Base85. Okay, and then we'll paste it in, and then we get this. So this is a URL. So we need to replace one of the variables in the script with this. So let's see. So Max says you can also suspect it via a pattern. Yeah, so if you see a pattern that looks like uppercase and lowercase letters and uppercase and lowercase letters and a bunch of numbers, it's probably going to be Base85 encoded. Okay, so this is the URL that we've got. We need to put this in the script. So we're just going to go over back to the TryHackMe machine, and in the C2 variable here, we're just going to type that URL in. So just going to get rid of what's already there, and the URL is https c2.northpole.thm/exfil. Okay, so after we've done this, we can save the script. So we'll go up to here, do File, Save, File, Save. Okay, and then we're going to open up our PowerShell terminal so that we can run the script. Just going to minimize this. We're going to go down to the Search tab, or the search bar, and look up PowerShell. Okay, and then they've got Windows PowerShell. We can click on this to open up the program. Now we've got our PowerShell terminal, and we're going to be using this to run the script. Okay, the Black Cyberduck says skip the last file in the path to check. Skip the last file in the path to check. Skip the last path in the file to check. I'm not too sure what this refers to, Black Cyberduck. Okay, so we're going to need to move into the desktop directory first. So cd desktop, and then we can run santastealer.ps1. So we're going to run the script by doing /santastealer.ps1. When we run the script from here, we're going to see that we've got a flag. So the flag is labeled THM-C2 deobfuscation. We're going to be supplying this to the to one of the questions. So let's just copy it now, and then go down to the first question here. What's the first flag that you get after deobfuscating the C2 URL and running the script? Paste it in and click on check. Okay, so I think there's one more thing we need to do, but we'll read up about what's going on here first. Okay, so it says here there's a second challenge waiting for you. This time you must deobfuscate the malicious actor's API key using XOR. Follow the part 2 instructions in the code's comments, and then run the script again to get your last flag. Okay, so we're going to go over here, back into the virtual machine, and then we're going to take a look at the script again inside of Visual Studio Code. Let's make this a little bit bigger. Okay, so part 2, obfuscation. So here what we're doing is obfuscate the API key using the XOR single byte key, hex 37, and then add the hex string to the obf API EEY variable. Okay, so this is it over here, and this is the value of the key that we need to obfuscate. So it's candy cane API key. We're just going to grab this and then copy it, and then go over to CyberChef. So in CyberChef, we're going to reset our environment, and then we're going to paste in this over here. So candy cane API key. So they tell us that we need to XOR encrypt this. So we're just going to type in XOR and then drag this into the recipe, and we're going to do hex 37. So 0x37, and I think they want us to do one more thing. Let me take a look. Okay, so XOR it using the single byte key hex 37 and then convert to hexadecimal. So we also need to do another transformation before we can paste this into the hex value here. So we're going to need to go to XOR, and we're in the operations. We're going to highlight this, and we're going to type in 2 hexadecimal. So 2 hex is over here. We're just going to grab this, and we're going to put this underneath the XOR operation. So we see here that the output now looks like a line of hexadecimal characters, which we can copy. And I'm just going to put it someplace where I can reference it. We're going to go back into the TryHackMe code, or the TryHackMe virtual machine, and we need to paste in the hex over here. So under API key, there's a section for hex. So I need to type in the hex. So 74767973 6E 1A 7476 79 721A 76 677E 1A 7 C72 6E. So the reason why I'm typing this out is because I can't get the copy paste I can't get the paste function to work when I'm getting the stuff from the outside location, but that's okay. It's not too long. Okay, so after that we can save out the script. So we're just going to go up here, File, Save, and then we can run the script again to get the last flag. Okay, and we'll just run the script one more time, and then we get the last key. So THM API obfuscation for the win. Let me just copy it. Okay, and then we will go back to the TryHackMe page. So what is the second flag you get after obfuscating the API key? Paste it in, check. Okay, and then we can click on this last box to finish the exercise. All right, everybody, this was a guided walkthrough for day number 18 from the TryHackMe Advent of Cyber event for 2025. This room was called Obfuscation, the Eggshell. If you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. Okay, we're not leaving, everybody. The Black Saber Duck says, nice, you don't have any curiosity to check the file code to check if it does contain any suspicious lines? I like your rooms, see you next time. No, we're not leaving. We're not leaving right now. It's just that I need to do this, I need to say these things to record my YouTube videos. But I mean, I'm kind of busy. I wish I could take a long time to check out each one of these rooms in great detail. But I've got to move on to the next exercise. But I mean, feel free to go ahead and try. Go ahead and try taking a look at the rest of the script, because it might have some stuff. I think this script right here might have the keys to the next, what is it called, side quest room. But let me go ahead and check that. So I'll terminate the machine, and then we'll go over to, oh, what is it called? So over here we've got, oh, Operation Save McSkitty. So this one actually leads to the third side quest room, which is Carrot Bane of My Existence. So if you want to check out the side quest stuff, it's going to be in day number, what is this one? This one is day number 17, I think. Okay, let's so we've got one more of these to do before we can move on to the next thing. Black Cyber Duck says, I know, but in general, always need to be aware of that in cyber awareness. For sure. But yeah. I mean, I'm sure there are more secrets to be had by checking out the rest of the script. It's just that I've got a bit of a deadline to hit here. Okay, let me move on to day number 19. Okay, so everybody, this is a guided walkthrough for day number 19 from the TryHackMe Advent of Cyber event for 2025. This room is called ICS Modbus Clause for Concern. Okay, so everybody, after you've joined the room, what you want to do is you want to go down to the first task over here. So task 1, they've got a little storyline that we're going to be catching up with. The snow falls heavily over Wareville as chaos erupts at TBFC headquarters. What should be the busiest shipping day of the season has turned into a disaster. Another chocolate egg? Shouts a frustrated warehouse worker, holding up yet another Easter-themed package. We're supposed to be shipping Christmas presents. The delivery drones buzzed overhead, their mechanical hum sounding almost mocking. Each one returns from its route empty, having successfully delivered its cargo. But the cargo is all wrong. You're called into the command center, where screens flicker with delivery statistics. Everything looks normal on the surface. 1,000 presents in stock, 98% success rate, and all systems are operational. But the phones won't stop ringing, with confused citizens asking why they're receiving chocolate eggs instead of the toys and gifts they've ordered. The logistics manager pulls up the delivery manifest. Look at this, she says, pointing at the screen. The system indicates that we delivered a teddy bear to the Miller family, but they received a chocolate bunny instead. It's the same weight, exact dimensions, but they're completely different items. Then on one of the monitoring screens, a message flashes for just a second before disappearing. Exploit version 6.66, property of Hopsec Island. Why should Christmas have all the fun? King Malheur. So someone has compromised the drone fleet's control systems. The attack is sophisticated, falsifying sensor data, manipulating inventory selection, and erasing all traces. This isn't just a prank. It's a calculated assault on Christmas itself. Your mission is clear. Investigate the TBFC drone delivery system, uncover how King Malheur's exploit team has compromised it, and restore Christmas deliveries before Sockmas is ruined. But be warned, King Malheur doesn't leave systems undefended. Traps are waiting for the careless investigator. One wrong move, and you might make things much worse. A mysterious delivery. As you walk through the warehouse control room, something catches your eye. A crumpled piece of paper on the floor near the PLC terminal. It looks like someone dropped it in a hurry. You pick it up and unfold it. The handwriting is hurried, almost frantic. TBFC drone control for maintenance only. So we've got holding registers. So these are the instructions that that control how to configure the what is it called? The ICS system that is doing the selection. Panakopanko says, Advent of Cyber, yippee! Panakopanko, hey, hello! So if you didn't know, Panakopanko is a live streamer who also does InfoSec streams. So let's give her a shout out. So if you enjoy a good, healthy dose of humor along with your hacking, please check out her channel. Okay, so we're just going to skip all this because it's just a bunch of code. So you stare at the note, confusion washing over you. Register map, coils, what is all this? The terminology is foreign, HR0, C11, Modbus scribbled in the margin, but something about it feels important, like a key that you don't know how to use. You pocket the note carefully. I'll figure out what this means later, you think. For now, you need to understand the systems you're dealing with. Little do you know, this crumpled note will be exactly what saves Christmas. So our learning objectives today. How SCADA, Supervisory Control and Data Acquisition Systems, monitor industrial processes. What PLCs do in automation. So PLC stands for Programmable Logic Controllers, and how the Modbus protocol enables communication between industrial devices. How to identify compromised system configurations in industrial systems, techniques for safely remediating compromised control systems, and understanding protection mechanisms and trap logic in ICS environments. Okay, so we need to do the following two things. Do we need to start the attack box today? Yes. Do we need to start a VM today? Yes. So we're just going to go down, and we're going to start our two virtual machines that we're going to be using for the exercise. So the target machine, click on the green Start Machine button, and we also need to click on the Start Attack Box button as well. So click this one as well, and you're going to see the attack box environment start loading up over here. It's going to take a couple of minutes, so we're just going to make this smaller, and we'll take a look at what's going on in the rest of the room. So we just need to click on the checkbox button here, and then move on to task number 2. So what is SCADA? SCADA systems are the command centers of industrial operations. They act as the bridge between human operators and the machines doing the work. Think of SCADA as the nervous system of the factory. It senses what's happening, processes that information, and sends commands to make things happen. So TBFC uses a SCADA system to oversee its entire drone delivery operation. Without it, operators would have no way to monitor hundreds of drones, manage inventory, or ensure packages reach the right destinations. It's the invisible orchestrator of Christmas logistics. Components of a SCADA system. So a SCADA system typically consists of 4 key components. So sensors and actuators. These are the eyes and the hands of the system. Sensors measure real-world conditions such as temperature, pressure, position, and weight. Actuators perform physical actions, motors turn, valves open, and robotic arms move. In TBFC's warehouse, sensors detect when a package is placed on the conveyor belt, and actuators control the robotic arms and load drones. So the second thing is PLCs, programmable logic controllers. These are the brains that execute automation logic. They record sensor data, make decisions based on programmed values, and send commands to the actuators. A PLC might decide if the package weight matches a chocolate egg and the destination is Zone 5, then load it onto drone number 7. We'll explore how PLCs work in detail in the next task. So number 3, monitoring systems. So PLCs are like Arduinos but bigger. So Arduinos are little circuit boards, right? I don't know very much about Arduino. If you could educate me, I would be happy to hear it, Panko. Monitoring systems. Visual interfaces like CCTV cameras, dashboards, and alarm panels, where operators observe physical processes. TBFC's warehouse has security cameras on port 80 that show real-time footage of the packaging floor. These monitoring systems provide immediate visual feedback. You can literally watch what the automation is doing. And 4. Historians. Databases that store operational data for later analysis. Every package loaded, every drone launched, every system changed gets recorded. This historical data helps identify patterns, troubleshoot problems, and in incident response scenarios like ours, reconstruct what an attacker did. So, SCADA in the drone delivery system. TBFC's compromised SCADA system manages several critical functions. Package type selection. The system decides whether to load Christmas gifts, chocolate eggs, or Easter baskets onto each drone. This selection is controlled by simple numeric values that determine which conveyor belt activates. Delivery zone routing. Each package must reach the correct neighborhood. Zones 1 to 9 represent different districts of Wareville, while Zone 10 is reserved for disposal, the ocean, a failsafe for damaged goods, but also a perfect target for sabotage. Visual monitoring. The CCTV camera provides real-time observation of the warehouse floor. Operators can view which items are being loaded, verify system behavior, and identify anomalies. This visual layer is crucial during incident response. Inventory verification. Before loading a package, the system can check whether the requested item actually exists in stock. When this verification is disabled, the system blindly follows commands, even if those commands are malicious. We got system protection mechanisms. Security features are designed to prevent unauthorized changes. When enabled, these protections monitor for suspicious modifications and can trigger defensive responses. Unfortunately, King Malheur has weaponized these very protections as part of his trap. And lastly, audit logging. Every configuration change, every operator login, every system modification should be recorded. Attackers often turn off logging to cover their tracks, and that's precisely what happened here. So why are SCADA systems targeted? Industrial control systems such as SCADA have become increasingly attractive targets for cybercriminals and nation-state actors. Here's why. They often run on legacy software with known vulnerabilities. Many SCADA systems were installed decades ago and never updated. Security patches that exist for modern software doesn't exist for these aging systems. Default credentials are commonly left unchanged. Administrators prioritize keeping systems running over changing passwords. In industrial environments, the mentality is often, if it works, don't touch it. A recipe for security disasters. Panko says, Arduino is set and forget. Oh, it's a microcontroller. Okay, you can write your code, upload, and it runs indefinitely. That sounds pretty cool. I mean, it's probably something I'd put on my increasing list of technologies that I want to check out eventually, but it's probably going to take me years to get there. But yeah, definitely very, very cool. They're designed for reliability, not security. Most SCADA systems were built before cybersecurity was a significant concern. They were intended for closed networks that were presumed safe. Authentication, encryption, and access controls were often afterthoughts at best. They control physical processes. Unlike attacking a website or stealing data, compromising SCADA systems has real-world consequences. Attackers can cause blackouts, contaminate water supplies, or in our case, sabotage Christmas deliveries. They're often connected to corporate networks. The myth of air-gapped industrial systems is largely fiction. Most SCADA systems connect to business networks for reporting, remote management, and data integration. This connectivity provides attackers with entry points. Let's see, Panko says, great talk on hacking PLCs. Watch later if you have time. So let me go ahead and save that link. I definitely want to check out all sorts of great hacking stuff. Thank you. Protocols like Modbus lack authentication. Many industrial protocols were designed for trusted environments. Anyone who can reach the Modbus port, which is 502, can read and write values without proving their identity. In early 2024, the first ICS OT malware, Frosty Goop, was discovered. The malware can directly interface with industrial control systems via the Modbus TCP protocol, enabling arbitrary reads and writes to device registers over TCP port 502. King Malheur has weaponized these same tactics, not to cause blackouts, but to sabotage Christmas deliveries by directly manipulating the control system through the Modbus protocol. In the next task, we'll explore the PLC, the component he's actually compromised. Okay, so we'll answer the questions. What port is commonly used by the Modbus TCP? So they tell us it is port 502. So type in 502. Done. Okay, let's move on to task number 3. So PLC and Modbus protocol. So what is a PLC? So a PLC, programmable logic controller, is an industrial computer designed to control machinery and process in real-world environments. Unlike your laptop or smartphones, PLCs are purpose-built machines engineered for extreme reliability and harsh conditions. PLCs are designed to survive harsh environments. They operate flawlessly in extreme temperatures. Constant vibration, dust, moisture, and electromagnetic interference. A PLC controlling warehouse robotics might endure freezing temperatures in winter storage areas and scorching heat near the packaging machinery. Run continuously without failure. PLCs operate 24/7 for years, sometimes decades, without rebooting. Industrial facilities cannot afford downtime for software updates or system restarts. When a PLC starts running, it's expected to keep running indefinitely. Execute control logic in real time. PLCs respond to sensor inputs within milliseconds. When a package reaches the end of the conveyor belt, the PLC must instantly activate the robotic arm to catch it. These timing requirements are critical for safety and efficiency. And interface directly with physical hardware. PLCs connect directly to sensors, measuring temperature, pressure, position, and weight, and actuators, motors, valves, switches, and robotic arms. They speak the electrical language of industrial machinery. Okay, next, what is Modbus? Modbus is the communication protocol that industrial devices use to talk to each other. Created in 1979 by Modicon, now Schneider Electric. It's one of the oldest and most widely deployed industrial protocols in the world. Its longevity isn't due to sophisticated features, quite the opposite. Modbus succeeded because it's simple, reliable, and works with almost any device. Think of Modbus as a basic request-response conversation. Client, your computer. PLC, what is the current value of register 0? Server, the PLC, register 0 currently holds the value 1. This simplicity makes Modbus easy to implement and debug, but it also means security was never a consideration. There's no authentication, no encryption, no authorization checking. Anyone who can reach the Modbus port can read or write any value. It's the equivalent of leaving your house unlocked with a sign saying, "Come on in." Everything's accessible. So we got Modbus data types. Modbus organizes data into 4 distinct types, each serving a specific purpose in industrial automation. So they've got coils, which are digital outputs on or off, either 0 or 1. So is the motor running? Is the valve open? Is the alarm active? So the next one is discrete inputs. So this is going to be on or off. This is 0 or 1. Is the button pressed? Is the door closed? Is the sensor triggered? We've got holding registers. So these are analog numbers, 0 to 65,000 some odd. So temperature set point, motor speed, zone selection. And we got input registers, which are also analog inputs. Oh, so these are outputs versus inputs. Okay, so these are numbers, also between 0 and 65,000. Current temperature, pressure reading, and flow rate. So the distinction between inputs and outputs is important. Coils and holding registers are writable. You can change their values to control the system. Discrete inputs and input registers are read-only. They reflect sensor measurements that you can observe but cannot directly modify. So in the TBFC's drone system, you'll find holding registers storing configuration values. So HR0 is package type selection. So 0 gifts, 1 eggs, 2 baskets. HR1 are the delivery zones, so 1 to 9 for normal zones and 10 for emergency disposal. HR4 is system signature, a version identifier in this case, an attacker's calling card. So coils are controlling system behavior. So C10 is inventory verification, C11 protection mechanisms, C12 emergency dump protocol, etc., etc. Okay, so big fat chickens, hello, nice to see you here. And welcome to the stream. Okay, so remember that crumpled note that you found earlier? Now it makes complete sense. The maintenance technician was documenting these exact Modbus addresses and their meanings. So Modbus addressing, each data point in Modbus has a unique address. Think of it like a house number on a street. When you want to read or write a specific value, reference it by this address number. So critical detail, Modbus addresses start at 0, not 1. This 0 indexing catches many beginners off guard. When documentation mentions register 0, it literally means the first register, not the second. Okay, so we'll just skip over a little bit because this is getting a bit long. So Modbus TCP versus serial Modbus, we'll also skip over this part as well. If you want to read a detailed description of what's going on here, please go ahead and do so. But for the sake of time, we're just going to skip over to here. So Modbus has no built-in security mechanisms, no authentication. The protocol doesn't verify who's making requests, no encryption. All communication happens in plain text, no authorization. So there's no concept of permissions, and no integrity checking. Beyond basic checksums for transmission errors, there's no cryptographic verification that commands haven't been tampered with. So modern security solutions exist, like VPNs and firewalls. Modbus security gateways, they're all add-ons, not part of the protocol itself. Okay. Black Cyberduck says, emergency address and the last code are in the ocean, I guess. Yeah. Okay, so connecting the dots. Now that you understand why the OpenPLC web interface showed nothing useful, King Melhair bypassed it entirely. He connected directly to the Modbus TCP port and manipulated the registers and coils that controlled the system behavior. So the note that you found, the maintenance technician must have discovered what was happening and started documenting the compromised values. So the warning at the bottom, never change HR0 while C11 is true, suggests that they figured out the trap mechanism before getting interrupted. In the next task, we'll use Python and the PyModbus library to investigate the system exactly the way King Melhair attacked it, by directly reading and writing Modbus values. Time to see what he actually changed. Okay, so we'll just click on this button here, and we'll move on to the practical task. Okay. So now that you understand the basic concepts related to ICS and Modbus, we will analyze the compromised TBFC drone control system and learn how to safely restore it. So initial reconnaissance, we're going to be doing an Nmap scan now on this IP address. Let me just copy this. And then we'll go over to our attack box machine. So in the attack box machine, we're going to close this initial terminal, and we're going to open up another terminal to run our commands. So you can click on this terminal shortcut over here. Okay, and what we're going to do is we're going to paste in the nmap command. So what this nmap command is doing is it's a basic scan on a remote server, and it's going to scan these ports, so port 22, port 80, and port 502. When we run the command, actually let me run it a little bit faster than usual. Okay, that's going to take a little bit of time, but in the meantime we can read about what's going on. So the key findings from the scan, so the scan will come back in a couple of minutes. So port 80, which is the HTTP service, this is the CCTV camera feed. And we got port 502, this is the Modbus TCP, the PLC communication protocol. So this is typical of an industrial controls system setup, a web interface for monitoring, and Modbus for programmatic control. So visual confirmation, the CCTV feed. Before diving into technical details, let's see what's physically happening in the warehouse. So Black Cyberduck says, SV is the service version. Yeah, so we're just trying to find the version of the whatever services we find with the nmap scan. So navigate to this in your browser. So we just need to copy this address, then go over to our attack box. So in the attack box, we need to start up the Firefox browser. So that's this shortcut here. And we need to supply the address. So after that starts up, we're going to paste in the address and then go there. Okay, so this is what's happening. So it says status compromised, disarmed. So this is the warehouse floor. That's this is like a live camera feed. And this is the warehouse that's shipping all of these Christmas gifts and stuff. All right, let's move on. Okay, through the security camera, you see that the warehouse floor in real time, robotic arms are busy at work, and conveyor belts are running smoothly. Something is wrong. Instead of Christmas presents, you see pastel-colored chocolate eggs being sorted, Easter-themed packaging on the assembly line, and delivery drones loading eggs instead of gifts. The status display in the corner shows compromised. This visual confirmation tells you that the program is real and active. The system isn't broken, it's working perfectly, just delivering the wrong items. This is a classic sign of a logic manipulation attack rather than a system failure. Keeping the CCTV feed open in a separate tab, it will update you as you make changes to the system, providing real-time feedback on your remediation efforts. So Modbus reconnaissance. We'll need to interrogate the Modbus server directly. This is where Python and the PyModbus library become essential. Remember that crumpled note that you found earlier? Pull it out now. The terminology that seemed foreign, HR0 C11 Modbus, is about to make perfect sense. Steps 1 to 5 are optional. You can read along with them. So we're just going to do a few of these steps over here to match up with what's going on inside the task over here. So we're going to establish a connection to the PLC Modbus interface. So we're just going to open up Python interpreter over here. Where's our terminal? Here it is. Okay, so the nmap scan came back. Angel Vasquez says, "Sorry, I stumbled upon your channel. What's this all about? Is this some sort of cybersecurity contest?" It's not a contest. It's just these are a bunch of different cybersecurity exercises that we're doing for Christmas. So each day has some different cybersecurity concepts that they're covering, and if you wanna play along with us, you can make an account over at TryHackMe.com and then go over to this page. Okay, so here we're gonna type into the terminal Python 3. So this is going to start up the Python interpreter, and then we can start putting in our commands from here. Let's see if we can make this a little smaller. Okay, so we've got over here, from Modbus client, import Modbus. So we just need to copy the command over here, and then we'll go back and we'll put it into the Python window. Okay, and then we'll just paste it in. So here we're running commands from the Python terminal. So that imports the Modbus module, and then we can run some commands. So client equals Modbus TCP client, this thing over here. So we're just defining a variable. Okay, so this command here. So client equals Modbus TCP client with this IP address on port 502. So we define the variable over here, and then we can start issuing some commands. So if client.connect, well, we can actually just print this out. So print client.connect, and if it's connected, it should print out true. So it does print out true, which means we're connected. And the next thing we're going to do is we're going to read some holding registers. So result equals client.read holding registers, address 0, count 1, slave 1. Okay, let me copy this command. And then we will give this command in Python. Okay, paste it in, and then after we set the variable, we can print it out. So print result. So read holding register response is 1. So if the result is 1, then it's going to be chocolate eggs. Actually, wait. Wait. Okay. So results.register registers 0. We can print this out. And then we can find out what kind of package types are being handled here. So print result.registers register 0. Okay, so we got package type 1. So it's package type 1, which means it's chocolate eggs. Okay, and then, so we'll just we'll also take a look at the delivery zone, and then we'll move on to the next part of the task. So here, so client dot. Well, let me copy this. Okay, so result equals client.reading read holding registers address 1 count 1 slave 1. Okay, and then we will paste in this command to run it. Okay, and we'll print result. So this is read holding register response 1. And we want to take a look at what zone we're in. So result.register 0. We'll print it out. Is this 18 or 19? Says big fat chicken. So this one is 19. Print result.registers 0. So this tells us this is zone 5. So zone 5 is a regular delivery zone. Okay, and then we'll move on. So we can keep on querying the system to get different results here. But in this case, we're looking at, what are we looking at? The holding register for number 4, which is the system signature. So if signature equals 666, then print exploit detected. So system signature 666, exploit detected, King Malheur signature. Okay. So the value 666 confirms that the system has been compromised by the exploit framework. Okay, and then we read the coils. So coils are Boolean flags that control system behavior. And what we're doing here is we're checking inventory verification, whether or not it's being checked or not. So it's either going to be true or false. In this case, it is disabled. So inventory verification is disabled. The system is blindly following commands without checking if items actually exist in stock. Okay, and then we check coil number 11, which is the protection override. So if result is 0, then that means protection is turned off, otherwise it's turned on. And in this case, it's true, which means changes are being monitored. Okay, this is crucial. C11 is enabled, which means that the system is actively monitoring for changes. Remember the warning on the note. Never change HR0 while C11 equals true. Will trigger countdown. So we'll check if the self-destruct is actually armed. So read coil number 15, and this checks whether or not the self-destruct has been activated or not. And in this case, it is false. So good news, the self-destruct isn't armed yet, but it will be if we try to change HR0 while C11 is active. So if we try to undo this stuff while C11 is, let's see, which one is C11? So coil 11 is protection override. If we try to change anything while protection override is true, then it will trigger this self-destruct countdown over here. Okay, now the note makes complete sense. The maintenance technician discovered HR0 is set to 1, which is eggs, and then C11 protection is enabled, monitoring for changes. If anyone changes HR0 while C11 is true, then C15 gets armed. Once C15 is armed, a 30-second countdown begins. After 30 seconds, C12, the emergency dump, activates, and everything is dumped into Zone 10, which is the ocean. Okay, so we're going to complete the reconnaissance script. Let's create a comprehensive script to see the full system state. Exit the Python interpreter, and then create a new file. So we're going to do that in the attack box. We're going to exit from the interpreter. And then we're going to create a file called recon.py. So nano recon.py, and we're going to grab the code for the script from the TryHackMe task over here. So we're just going to copy paste all this stuff. Okay, so after we copy all of it, just going to go over to the TryHackMe attack box and paste it in. And then we're going to paste it into the nano text editor here. So after that, this is the script that we're going to run. we're going to save it, Control X to save, and then we're going to run the script. So Python 3 recon.py. Okay, so what do we have here? So we got all the stuff here. So package type is eggs, delivery zone is 5, system signature is 666, which is the malware signature, and inventory verification is set to false, but should be true. Protection override is false, emergency dump is false, audit logging is false, Christmas restored equals false, and self-destruct armed is equal to false. Okay, so we need to remediate the system. So now we have a complete picture of the compromise. Time to restore the system. So safe remediation. Based on our reconnaissance, we need to 1. Disable protection mechanism first, then change package type to Christmas gifts. Then we need to enable inventory verification, enable audit logging, and then verify that C15 was not armed. So the order is crucial. If we change HR0 before disabling C11, the trap triggers. We create the remediation script. Okay, so we're just going to go over to the attack box again. We're going to create another Python script. This is going to be called remediate.py. And then we're going to grab the code from over here in the TryHackMe task. Just copy all this. It's a pretty long script. Just need to go over to the end of it and then copy. Then we're going to go over to the clipboard, get rid of what's already there, and then we're going to paste into the clipboard. Okay, and then finally we're going to paste into the text editor. Okay, after we do that, we can save the file and then run the restoration script. Okay, and then let's go ahead and do that. So Python 3 remediate.py. Okay, so it just goes through the different steps to reset the PLC environment. So Christmas is saved. Yay! Christmas deliveries have been restored. The drones will now deliver presents, not eggs. Check the CCTV feed to see the results. Okay, we can go ahead and go back to the Firefox browser. And it says system restored. Uh-oh. Who is that? That doesn't look right. Anyways, we've got one more flag that we need to submit before we can finish the challenge. Okay, so the flag is here in the terminal. Let me grab this. And then we'll go back to the TryHackMe page. Okay, so what if you triggered the trap? If you had tried to change HR0 before disabling C11, here's what would have happened. So C15 self-destruct would arm immediately, a 30-second countdown would begin. After 30 seconds, C12 emergency dump would activate, HR1 would change to 10, the ocean zone, all the remaining inventory would be dumped, the CCTV would show the trap activation, you would need to restart the challenge. Okay. Alright, so post-incident analysis. So King Malhair's attack was sophisticated because it used unauthenticated Modbus access on port 502, manipulated the configuration values directly at the protocol level, disabled safety mechanisms, implemented a trap to prevent easy remediation, and left his signature as a calling card. So the maintenance technician who left the node likely discovered the compromise but was interrupted before they could fix it. Their documentation saved Christmas by warning about the trap mechanism. Congratulations! You've successfully investigated and remediated industrial control system compromised. You've learned how SCADA systems work, how PLCs operate, how Modbus communication functions, and most importantly, how attackers can manipulate these systems and how to safely restore them. What's the flag? So we copy the flag, and we can click on check, and then we'll finish the machine and the challenge by clicking on this. All right, thank you very much, everybody, for watching this guided walkthrough. If you enjoyed this guided walkthrough for TryHackMe Advent of Cyber Day number 19, ICS Modbus Clause for Concern, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs out. All right. We finished that. That took a while, but thank you very much for watching the demonstration. So Black Cyberduck says, you told you there was a trap. The code is manipulated, needs to be fixed. Drop the Discord channel. Yeah, we've got a Discord. It's over here. And we're going to be moving on to the next part of today's stream. So let me go ahead and set that up. So topic 1 is done. Topic 2 is here. Topic 3 is on deck. Okay. So this is going to be HackerFrogs AfterSchool, and we're going to be taking a look at privilege escalation techniques for Linux. And we're also going to be using TryHackMe.com. So let me go ahead and set that up. If you ever want to know all the steps that we're going to be doing during this demonstration over here, this lesson, it's going to be over here on the GitHub. And let's go ahead and start the lesson. I should probably put a time limit on this as well, so we got 60 minutes. All right, everybody, this is HackerFrogs AfterSchool, network hacking session number 10. So this is the last official session for network hacking, this course. But we're going to be doing a couple of extra exercises in the next couple of streams that are going to be going over some easy network hacking exercises, just so we can reinforce all the stuff that we learned during the network hacking course. So welcome to HackerFrogs AfterSchool. This is the 10th session for network hacking. Let's go over the concepts we covered in the previous session. So in the previous section, we were also talking about privilege escalation. And, hold on. So privilege escalation is called PrivEsc and is the act of upgrading the level of the access on a system, typically through abusing insecure settings or capturing credentials. So privilege escalation is a pretty major topic in cybersecurity, and we talked about a few different ways we could do privilege escalation on a Linux machine, and the first one was privilege escalation via sudo. So if a user has access to sudo with any command, there's a possibility of abusing that command for privilege escalation. So sometimes the user that we're using has sudo access with one particular command, and sometimes we can abuse it to do privilege escalation. We also talked about privilege escalation via SUID. So SUID binaries are a particular type of binary on the Linux system, and they're commands that are run in the context of the file's owner by default. Most SUID binaries are owned by the root user, and certain SUID binaries can be used for privilege escalation. We talked a little bit about how to tell what binaries are SUID on a Linux system, and how to find out whether or not they can be abused. And we also talked about kernel hacks. So kernel hacks are hacks that target the lowest level of operations in an operating system, that is the kernel. Typically, older versions of operating systems are vulnerable to kernel hacks. So today we're going to be covering 3 other types of privilege escalation on Linux systems. Those are going to be privilege escalation via path hijacking, privilege escalation via capabilities, and privilege escalation via cron jobs. So we'll explain what these all are while we work through this workshop. So we're going to access TryHackMe. So if you have a free account over at TryHackMe, you can access this room, and not everything on TryHackMe is free, of course, but the stuff that we're going to be covering is. So this is the link. Let me go ahead and access that room. Okay, so let me terminate my attack box. We don't need it. So I think the first topic we're going to be talking about is privilege escalation via path hijacking. So we'll talk about exactly what that means. But first we need to access the the task that has path hijacking. So I think it is this one, task number 10. So after you come to this room, Linux privilege escalation, you want to click on task number 10. So privilege escalation path, click on that, and then launch the target machine. So you can launch the target machine under task 10, click on the green start machine button. And it looks like we're going to need to use the attack box to access this. Okay, so we can start up the attack box by going up to the top of the room. And there's a button underneath the icon here that's labeled Start Attack Box. We want to click on that. And that's going to load up the attack box, which we're going to be using to access the vulnerable machine. But while it's loading, we can talk a little bit about Linux paths. So in Linux, the path variable is a list of directories where the system will look for command binaries. So for example, if I've got my Kali Linux machine here, I can echo out the path. And these are the directories where the system is going to look for binaries to run. So for example, if we look up, for example, the wget command, it says that the wget command is in this directory here, user bin. So the only reason we're able to use the wget command without referencing its full path is because it's this directory right here, user bin, is in the path variable. So user bin is, where is it? It's here. So this is one of the many directories inside of our path. So the different directories where the system is going to look for these binaries are separated out by these colons over here. So it's going to look for the binaries in home shyhat local bin, and then it's going to look in user local sbin, and then it's going to look in user sbin, etc., until it gets to the end of all of these directories. If it can't find the command in any of these directories, it's going to return to us that the command is not found. So for example, if I just do random command, it says random command not found. That's because the random command binary isn't found in any of the directories in the path over here. Okay, so for example, if you use the whoami command, Linux will first look in the user local sbin directory for this command first, then look in the user local bin directory until it gets to the end of the path directories. So if we locate a privileged script, which has a command that if we can locate a privileged script, a command that we can run with sudo permissions, or an SUID binary that is using another binary without an explicit file path, then we could potentially do some path hijacking. So we'll talk a little bit more about this after we log in. Let's go ahead and do this. So over at the TryHackMe room, we see that our attack box has finished loading up, and we need to access the remote server with the Karen username and the password password1. So we're just going to go over, we'll go up to the top of the screen where we can get the target machine information. We need to get the target IP address, copy it, and then move over to the attack box here. So in the attack box, we need to paste in the IP address because we're going to be using this. So paste it into the clipboard, and then open up a terminal. So we can open up a terminal with either this shortcut or this shortcut or this shortcut. After we do that, we're going to log into the vulnerable server. So the vulnerable server is going to be here. We're going to SSH into it using the Karen user with this command right here. So after we do that, it's going to ask us if we want to continue connecting. The answer is yes, and we have to supply the password. The password is password I think it's password 1. Password 1, this thing right here. Okay. So I'll just type it out. Password 1. So if you're concerned that you don't see any input while you're typing in your password, that's because it's not supposed to. Just hit enter after you type in the password, and now we're logged in. So we're logged into a remote server as the Karen user. If we ask who am I, it says we are Karen. I think we can make things a little bit bigger. Just a second, everybody. Okay. So I think what we want to do is we want to locate a script that is being used by the system, or maybe it's in our home directory. cd home Karen, cd home. Okay, so they got Matt, Murdoch, and Ubuntu. So there's a script that we want to take a look at. Hold on, I've got my notes over here. So everything that we were doing today are in these notes in the GitHub file. So we're currently doing part A, privilege escalation via path hijacking. Okay, in the terminal, use the following command to see the contents of the root-owned test file. The test file. Just a second, everybody. I need to reacquaint myself with this challenge. Where is the test file? Let me try finding this test file. Just a second, everybody. Find / name test. Turns out there's a lot of, home Murdoch test. Okay, we need to move into the home Murdoch directory. So cd / home Murdoch. Okay, so there is test. So if we try running test, it says THM not found. So THM not found, it means that we run this binary, and because the binary is trying to reference something called THM, we might want to investigate this further. So just a second. Okay, so what are we doing here? If we can locate a privileged script, a command that can run with pseudo permissions, or a SUID binary that is running another binary without an explicit file path, then we can add a writable directory to the path, then create a malicious version of whatever command is being referenced in the privileged binary or script. And now when we run the privileged file, it will open up a privileged shell. So let's go ahead and try this out. So we've got our directions over here. So when we run tests, we note that the binary is looking for the THM binary. Let's check the path variable for the terminal. So we can go over here and echo path. So the path is user local sbin. So it's looking for the binaries in these different directories here. And what we can do is we can add something to this path. So if the binary is looking for the THM binary, and we can add the THM binary to a directory that we control, such as the temporary directory, then we can do the path hijacking. So this is how you do it. So these are all standard path directories. If we add a writable directory to the path, then we can hijack the test binary's dependency on the THM binary by writing our own THM binary. So use the following command to add the home Murdoch directory to the system path. So export path equals home Murdoch and then append the regular path. So we're just going to grab this command and then we will paste it in here. And then we will run this command. So this is what we're going to, this will add the home Murdoch directory, which we can write into to the rest of the path variable. So if we echo the path again, we see that the home Murdoch directory has been added to the path. So our current directory is home Murdoch, and we can write to this directory. So this isn't normal. You're not supposed to be able to write to other users' home directories, but in this case we can for some reason. Okay, so this is what we're going to do. So use the following command to start the nano text editor to create a malicious THM file. And then we're going to put this script inside of the malicious THM file. So we're just gonna copy this. We're gonna go over to the attack box again and paste in the command. Okay. We're gonna run nano to create the a file called THM, and then we're going to paste in our code or the script. So the script is going to run bash p, which essentially means that it's going to open up a shell for us. So we save the file, and then we need to make this file executable. So THM is not executable right now. We need to make it executable by doing chmod plus x for THM. So after we do this, we can run the test command again, and the test command, we didn't point this out before, but the test binary is actually an SUID binary. And the way we know this is an SUID binary is because it has the little S over here. So an SUID binary is a binary that runs as the file owner, which is root, which means if we run test and test runs THM and THM gives us a shell, then it'll open up a root shell for us because test is owned by root and is an SUID binary. Okay, so we can just run test now. So we'll do a check. So who am I? Karen. We run test, and then we become the root user because the test SUID binary is making use of THM, which we created and added this particular directory to our path variable. So we did a path hijacking attack. Okay, we've got ads running on Twitch right now. So when ads run on Twitch, we run them on YouTube. And you know what? Let's go ahead and play a little bit of music and put on the birds. So I love my birds, and these are some northern flicker woodpeckers. Enjoy the birds. We will be back in about 60 seconds. I just need to take a little water break. Bit008 says, birds. Hey, yeah, they're birds. All right, let's put away the birds and we'll get back to the hacking. Okay, so we've got another privileged script here as well called THM. So let's go ahead and take a look at that. Okay, Edgar says, is your job pen testing related or do you do this for fun? Well, I do this for fun. I used to work in pen testing, but I don't work in pen testing anymore. I worked in pen testing for about half a year, and I decided that I'd rather do education rather than doing pen testing. But Edgar, hello, and welcome to the stream. Okay, so we're just gonna get rid of the. Actually, wait. So we've got root access now. We successfully did our privilege escalation, but now we're going to go back to being the Karen user here by exiting, and then we're going to delete the THM. We're going to delete the THM binary. Well, do we need to? The other thing we can do is we can take a look at this thm.py script over here. So sometimes we can take control of elements that are being used by scripts, especially if they're scripts that are being run with elevated privileges. So let's take a look at thm.py. Okay, so here it does this command. So this Python script, it imports OS, it imports system, and then it runs OS system THM. So it runs, oh, okay. So this runs the THM command. So it runs the THM command, and if we've got, if we have a malicious binary here that gives us a shell, then it's going to give us our root shell. So sometimes you can get we can do a script hijacking, and the script hijacking also is a form of path hijacking, because Python scripts generally use, well, okay, we're not actually taking advantage of script hijack. Well, it is script hijacking, but not it's not Python module hijacking in this case. So let's go ahead and try running the thm.py script. Oh, where's Python? Python 3? Ah, okay. So we'll run Python 3 thm.py. Python 3 thm.py. Why does it give us a syntax error? User bin Python 3. Hold on. Let me take a look at my notes. Okay, so let's move on then. So we're going to move on to part B, which is privilege escalation via SUID binaries. Whoa, wait, what? It shouldn't be. Oh, this is mislabeled. This should be privilege escalation via capabilities. Let me go ahead and edit this real quick. Just a second. So path hijacking, capabilities. Okay, so this is part B. We're going to be doing some privilege escalation via capabilities. Let me go ahead and go into the TryHackMe machine. We're just going to exit out of here in the terminal. Exit. Okay, and then we're going to terminate the machine over at the top of the screen. So at the top of the TryHackMe page, we click on terminate. And next, we're going to go to the task which has the capabilities. So this is task number 8. So go ahead and click on that. And we're going to start the machine associated with this part here. So under task 8, click on start machine. And that's going to start up the target machine that we're going to be using SSH access to get access to. Actually, wait. It looks like we don't need to use the attack box. That's good. So this is just going to run. Well, it's just going to load up the virtual machine. But in the meantime, we can talk about this next thing over here. So privilege escalation via capabilities. So capabilities is another method we can use for privilege escalation. And capabilities in Linux are a feature which allows for certain binaries or commands to run with additional privileges. So for example, over here, the home Karen Vim application, or the binary, it runs with capsetuid plus EP, which is not great. Edgar says, is SUID like a regular user running a file belonging to the root user, is if they have the same permissions of the root user? So let me talk a little bit about SUID, sure. So SUID binaries, let's make this nice and big so that we can read it. So run in the context of the file owner. So SUID binaries run in the context of the file owner. So if the SUID binary is the ls command, for example, every time we run ls, it's going to be able to read sensitive directories, or even the root directory, because it's running as the root user. So, well, most SUID binaries are owned by root, which means most SUID binaries run as root. So I hope that makes it a little bit easier to understand. If you still have more questions, please feel free to ask them in the chat. Okay, so capabilities. So capabilities are a feature that allows for certain binaries or commands to operate with additional privileges. So capabilities are a little bit like a more granular version of SUID binaries. So SUID binaries, they just blanket run in the context of another user, but capabilities are a little bit more nuanced. So as opposed to SUID binaries or pseudo permissions, capabilities allow granular control over binaries. So we can return binaries with modified capabilities by using the getCap command. So we can go over to, so we've got our privilege escalation box running over here. That's good. I think we are running as the Karen user. Yeah, so we're running as the Karen user, and we can see which particular binaries have modified capabilities by running the getCap command here. I think it's getCap, is it getCap H? Let me look it up. So getCap-R. So getCap-R/, which means we look everywhere, and everything that is an error message, we redirect to dev null. So let's go ahead and try that out. We can't paste into here. That's a bit of a bummer, but I can just getCap-R to dev null. Oh, wow. Like this. And it'll let us know what binaries have additional capabilities. So we've got typically in most Linux environments, there are legitimate getCap, there are regular binaries that have additional capabilities, which are completely normal. So if we go over to our Kali machine here and run getCap-R, do we not have any on the system? Maybe we don't. Anyways, we'll just leave this running. And in the meantime, we can just take a look at what's going on here. So let's see, user bin, trace route, something, something. So the good thing about this is that it gives you a list of different binaries. And if you suspect that any of these capability binaries might be vulnerable, you can just copy out the entire list. And we can give this to a friendly AI. So let me copy this. We'll go over to our AI friend. How about Claude? So here's Claude, and we will ask the question: are any of these extra capability binaries vulnerable. Okay, and then we'll paste in the list. Edgar says, got it. So running binaries with the owner's permissions. Seems like the goal is to run as root in hacking. I mean, that is a goal. That is a goal for sure. Getting control of the system as the highest level user. It's a typical end game in cybersecurity exercises, but it's not the only goal. Sometimes the goal is just to read a sensitive file. Okay, so I think this is a pretty good use of the AI. You can give it a long list of different things, and you can have it run and do a little bit of research on each one of these. So it says, yes, 2 of these are highly vulnerable and can be abused for privilege escalation. So over here, it is home Karen Vim with cap set UID plus EP. So extremely vulnerable direct root shell. So it'll show you how to do this. So I mean, the problem is you don't want to give any extra capabilities to text editors because text editors are often very, very powerful in Linux. So in this case, the text editor can, let's see, why it's vulnerable. So cap set UID allows the process to change its UID to any user, including root. So Vim can execute Python shell commands, and you can get an instant root shell. So in this case, we can set the UID to root's UID, and then we can get a root shell. So so Vim is over here. We can just copy this command. So this is what the command looks like. I don't think we can paste into this machine, can we? Oh, we can. Wait, can we? No, I don't think we could. Okay. So we're just going to run the Vim binary like this. So it's home Karen Vim command. So the Vim command can be instructed to run system commands as well, which is another reason why these kind of capabilities are especially vulnerable. So pi3 import os and then os dot set uid equal to 0. So uid 0 is root's uid, and then os dot execute l bin bash dash -p. So what this is going to do is it's going to, oh, I don't think I spelled everything correctly there. So -p. Okay, so what this is going to do is it's going to use the Vim binary that has the extra capabilities to set our UID to root's UID and then open up a shell. So if we run this, then we become the root user. So who am I? Who am I? Root. Unfortunately, my terminal is kind of busted right now, but we did become the root user. So I guess we can do this.
What are you? I'm system root.
Okay, so busted terminal or not, we are now the root user, so we can, oh, but man, this, hold on. So another thing we can do is we can, if we suspect that something might be vulnerable through capabilities, we can look over at GTFO bins. So GTFO bins is a repository of different privilege escalation techniques you can do with Linux and Unix binaries. And we can look up the entry for Vim. Okay, so Vim here, we've got capabilities. So we're just going to click on that. So if the binary has the Linux capset UID capability set or is executed by another binary with the capability set, it can be used as a backdoor to maintain privileged access by manipulating its own process UID. This requires that Vim is compiled with Python support. So prepend py3 for Python 3. Okay, so I think this is probably the better command we can use. So let me try this one instead. So we'll run this command in the terminal here. So we're just going to exit. Okay, the terminal's all screwed up. I'm going to terminate this machine and then I'm going to restart it. Okay, so capabilities, I'm going to restart the machine. We'll be back in just a couple of minutes, but in the meantime, we can talk a little bit more about this. So we can return capabilities with modified binaries with modified capabilities by using the getcat command, which we did. And we can also feed the list of capability binaries to an AI to discover if any of them are potentially vulnerable. So this is what we did right here. It's a pretty good use of the AI in my opinion. So once a potential vulnerable binary is found, we can check how to use it for privilege escalation using the GTFO bins website, which we also did. Okay, so let's go ahead and we'll try doing this one more time, and then we'll move on to the final method of privilege escalation that we're going to be talking about today. Okay, so we got our Vim binary here. We're just going to give the command that was recommended to us by GTFO bins. We're going to run vimc py3 import os. And thank you very much, Shifty, for subscribing on YouTube. Thank you very much. So where are we? Import os, and then os.set UID to 0. And then os.execl bin, well, let's do bin bash, and then bash, and then -c, and then reset exec bash. And let's see if this command works. Oh, I made some sort of syntax error. Okay, let's try that one more time. vimc. Oh, okay. I screwed it up like from the get-go. So let's see. vimc py3 import os os.set UID to 0. Bin bash bash -c reset exec bash. Okay, so do we become it doesn't seem like it worked. Okay, so anyways, we managed to get this working with the other command, but this terminal is a little bit finicky because it doesn't let me copy paste, which means it's a bit of a pain in the butt to type everything. So let's move on to the next to the last privilege escalation technique. We'll go back up to the top. We'll terminate this machine. And then we'll go over to, I think it's task number We'll go to task number 9. So task number 9 is privilege escalation via cron jobs. And we need to start up the machine. So click on task 9 and then click on start machine. Okay, so this is going to start. But in the meantime, we'll talk about what exactly cron jobs are. So privilege escalation via cron jobs. So cron jobs are a feature in Linux which allows certain binaries or scripts to run at regular intervals. So for example, you can run a script or command once a minute, once an hour, once every day, etc., etc. And this process in Linux is called the cron job. If we're able to modify a script that is being used for a cron job, if we're able to modify a component that the cron job command or script uses, then we can potentially escalate our privileges. So thank you very much for following on Twitch, Raffle Streamer. Thank you very much. You're now HackerFrog. Okay, so in this screenshot over here, there's a backup script. So backup.sh. If we can use some part of the backup script, and if it's being used as a cron job by another user, for example, the root user, then we could interrupt the process and get we can have the cron job run any command we want. So we'll talk about how we do this in just a sec. So we're just going to go back to our TryHackMe machine here. So we have this backup.sh script in here, and Archero, hello, nice to see you here. And so the backup script is this one over here, backup.sh, and it's owned by our user. So our user is Karen. And let's take a look at what's inside this script. So cat backup.sh. So the script it moves into this directory here. So home admin 123 results. And then it runs the zip command. So zip our home admin download.zip into the current directory. Okay, so it runs zip. It creates a file called download.zip from all the contents of the current directory. So the current directory is going to be this directory here because that moves into that directory. And it just makes up a zip file from everything in that directory. So, it kind of makes sense because the script is called backup.sh. So what we can do is we can take a look at the different cron jobs on a system, typically by running this command. I think it's cron tab -L. So no cron tab for Karen. Let me take a look at my notes. Okay, so this is privilege escalation via cron job abuse. So in this section, we're going to be doing privilege escalation attacks through abusing Linux cron jobs. So, okay, so there's a file that we can read called etc cron tab. Let's go ahead and do that. Cat etc cron tab. Okay. So these are the cron jobs that are being run on the system, and you can tell how frequently they're being used from this output right here. So a star in the first slot, or sorry, a dot in the first slot here means every minute. So every minute, it's running all of these commands. So as root, it's running antivirus.sh. It's running home Karen backup.sh, and it's running test.py. So these are all being run as root. So if we can somehow inject ourselves into any of these cron jobs, we can run arbitrary commands. So if root is running backup.sh, then we could probably use this for privilege escalation. So how are we doing this? So the backup.sh script is being run as the root user as a cron job, but our user owns the file. So we can write whatever commands we want to it. So use the following commands to make the backup.sh file writable, and then start up the nano text editor to modify it. Okay, so we can do that over here. So we have backup.sh. And right now it's not writable, which means we can't modify the file. But because we own the file, we can just make it writable with this command right here. So chmod plus W for writable to backup.sh. So after that, we can modify the file now. And what are we putting into it? So replace the contents of the script file with the following code. So we're going to copy, okay. So this is a pretty fun technique in CTFs. It's basically making a version of the bash binary that we can run that gives us root privileges. So we run copy bin bash, and then we copy it to the home Karen directory as a file called root bash. And then we give the root bash binary, SUID permissions, which means it's going to be an SUID binary for bash. So we talked about SUID binaries in the past. This script is going to be run as the root user. So it's going to make an SUID binary of the bash binary that we can use to get root access. So we're just going to copy this. Actually, I don't think we can paste in, but I think we can, Yeah, we can't paste into here, I don't think. Nano backup.sh. Okay, we're just going to delete everything else here. Can we paste? Nope, we can't paste. Let me see if I remember how to do this. So it is copy bin bash to home Karen. And Archero, hello, nice to see you here. And RMCH, hello, nice to see you here as well. So home Karen root bash, and then we do chmod u plus s. I think that's u plus s on home Karen root bash. And I guess what we should also do as well is, yeah, I think these are the only two commands we need to do. Let me double check. So copy bin bash into home Karen root bash, and then chmod u plus s to make it SUID binary on home Karen root bash. Okay, so we'll save this out. So Sir Infrahat, hello, nice to see you here. I'm late, no worries about being late. It's fine. So we see here backup.sh. If this is being run as a cron job, in about 30 seconds or so, we should get the root bash binary copied over to this directory as an SUID binary. Okay, so we will wait a little bit. So we know that the backup.sh, oh, this is not executable. Oh, this is not executable. Okay, so we need to make it executable. Chmod plus x backup.sh. So it's not going to run if it's not executable. Okay, now we've got root bash. So root bash is in here. So we're just going to double check. So root bash is an SUID binary that's owned by root, but when we run it, we will become the root user. So let's go ahead and do that. Okay, so who am I? Oh, we're still the Karen user. Hold on, let me get out of here. We'll try running root bash again. -P to preserve the preserve our permissions. Okay, so now we're the actual root user. So who am I? We're now root, which means we can do this.
What are you? I'm system root.
Okay, it looks like we've got ads running on Twitch, so we're just going to take a little ad break. So I'm going to take about 20 seconds to have a little bit of water, but in the meantime, you can enjoy the birds. How about these birds? Okay, we'll be back in about 20 seconds. Enjoy the birds. All right, let's get back to the hacking. So I think there's one more file that's being run as a cron job, so we'll demonstrate how to get in the way of that one as well. So cat etc cron tab. So root is running the antivirus.sh script. They're running the backup.sh script, and they're also running the test.py script as well. So let's exit out of the root bash and become the Karen user again. Let's take a look at what exactly the test.py script is. Oh, it doesn't exist. So it's trying to run temp test.py, but there's no such file as temp test.py. So what we can do is we can create our own Python script that that can run whatever commands that we want. So let's go ahead and do that. So what do we want this thing to do? We want the thing to, well, I think what we want to do is we want it to do the same kind of thing. We can make the Python script run the command to create the root bash suid binary as well. So first of all, let's just get rid of it first. Bro are live. Hello, nice to see you here. Are you real? Yeah, completely real. Gamer GG's19. Hello, nice to see you here. We're just talking about some Linux hacking techniques right now. But we're going to be talking about cryptography stuff in about 10 minutes or so. Uh-oh. Looks like the Linux machine has decided to not work. Let me reload the page. Okay, so over here. All right. So we're trying to create a new cron job. Well, we're not creating the cron job, but we're hijacking the cron job to do whatever we want. So we'll move into the temp directory, and then we will create a file called test.py. So the file, it's going to be a Python script. Gamer asks, are you real BR? BR. What does BR mean? I'm new, I want to learn. Yeah, no worries. So Gamer, let me know what your current level of knowledge is as far as like tech stuff is concerned. So are you comfortable with computers? Have you learned about any programming languages? What kind of stuff do you do? Then I can give you like a recommendation on where to start learning. So we're just going to create this file. We're going to call it test.py. So import so this is a Python script, of course. We need to do shebang user environment Python 3, and we'll just go in here. I want to learn ncat. Want to learn ncat. Okay, let me give you the starter pack. So the first two links over here, there's some YouTube courses teaching people about basic IT stuff. So it's called the A+ certification. That's the first two links. The third link is for computer networking stuff. That'll teach you about basic computer networking so that you can get started with your hacking journey. The fourth link is going to be for easy security exercises. You're going to need to make an account over at PwnedLabs, but it's a very, very good website. Try out some of those. Some of the challenges in the video playlist in the fourth link, and it'll help you get on your way to learning about hacking stuff. Okay, so we want to do import OS, and then we'll do, how do we run the thing? It's been a while. So Python OS run Linux command. How do we do that? Subprocess module, subprocess run. The older os.system function is simpler but less flexible alternative. So I mean, I want to use OS system. Oh, okay. So I just do OS system whatever we want, right? Hold on, let's go back. So import OS, os.system. So OS system, we want to run a certain command. We want to run copy bin bash, and we want to copy it to home Karen. We'll call it pi bash. Okay, and that's the first command. So the second command is going to be okay. Bro, you're so good, really hard working. I mean, I'm trying my best. If I can help some people get into cybersecurity, I'm happy, because that's what I'm trying to do here. So what are you doing now? We're just writing a little script to do some system hacking stuff. So we discovered a system which runs whatever Python script we want as the highest level user. So we're just going to create the script, and we're going to make the script copy over a program that we can use to become the root user, the highest level user. So we're going to do chmod u+s for home Karen pi bash. Okay, save that out. And let's move back into the home Karen directory. So if the cron job is actually running, then we should see a pi bash file appear here in just a second or two. Maybe it's not. Hold on. Let me take a look at the contents of the thing. So sometimes I get the syntax wrong. So in this case, I'm just going to check with our good old AI friend over here and ask, is there anything wrong with this Python script? Okay, paste it in. Okay, what is GNU Nano? So Nano is a text editor, and is this another PC? So yeah, we're logged into another PC. There's a critical error in the shebang line. Oh, okay. User bin environment Python 3 is correct. Okay, so I screwed up the syntax here. So I need to go and correct that. Let's go back in, test.py. So user bin, what was that again? User bin environment. Okay, I've gotten this wrong before. Okay, so now it should be able to run, and it should create a new file in here in just a second. Caesar Edits, new subscriber here. Hello, nice to see you, Caesar Edits. Nice to see you here. And what is up? You know what? Let's give everybody a fun video redeem. How about some Hack the Planet? Because that's what we try to do here.
Hack the planet! Hack the planet! Shut up and get in.
Oh, you know what? I think...
Hack the planet! Hack the planet! Shut up and get in.
I think what we want to do is we want to... So, okay. So this is...
Hack the planet! Hack the planet! Shut up and get in.
Thank you very much for the Hack the Planet redeems, Caesar Edits, and Gamer. Thank you. Okay, so I think what we should do here is we're not necessarily going to be running this as Python, because apparently it's not really running. Actually, let's go into the temp directory to figure out what's going wrong with this thing. So test.py, this is also not executable. So we'll make it executable. So that the cron job can actually run on it. Okay, Van Tien says, I watch your stream and practice the Priv-esque topic on Windows. Oh, Windows Priv-esque. Yeah. And Unkwooski, thank you very much for coming by. Thank you very much. Okay, so I think what we need to do is we need to go back in to the file and to the temp, what was it? Temp test.py, and we're not going to treat this, we're not going to treat that as a Python file. We'll treat it as a bash file. So that means we can just keep everything here. We'll just run these two things here. And we'll use, what was it, user bin bash? How does the shebang line actually... So it's like Linux bash script, shebang. Why is it not working? What is chmod? So chmod is basically, chmod is a command that changes file permissions. Bin bash. So shebang bin bash. I think that's what we need to do here. So this will make sure that it's treated as a bash script, not a Python script. So okay, so it instantly worked after we changed it over to a bash script. So we should be able to get root user privileges if we use this file over here called pybash. So we run pybash -p, and now we're the root user again. Awesome. Gamer says, why are you using a CLI instead? Why are you not using CLI? Mulgars, hello, nice to see you here. Why are you not using CLI? Instead, install CLI of Google or Qwen. I'm not too sure what you're asking for here. I mean, I'm using a CLI terminal. This is just a virtual machine that's running on top of the web page here for TryHackMe. Okay, so that was the last demonstration that we're going to be doing today, and let's talk about what we learned in today's workshop, and then we'll move on to the next thing. Like in AI terminal. Oh, I mean, are you talking about this one? I mean, okay, I could be using a CLI for the AI stuff, but I mean, I don't have it installed. It might be better to do. I haven't gotten around to installing it yet. Okay, so over here, so let's review the network hacking concepts we learned in this workshop. So we did privilege escalation via path hijacking. In Linux, the path variable is a list of directories where the system will look for command binaries. So a system's path can be used as a vector for privilege escalation if privileged programs use other commands without explicit file paths. So this is pretty common in your easy level CTF challenges. We talked about privilege escalation by capabilities. Capabilities in Linux are a feature which allows for certain binaries or commands to operate with additional privileges. Capabilities can be used for privilege escalation if the capabilities are given to certain binaries or commands. And lastly, we talked about privilege escalation via cron jobs. So cron jobs are a feature in Linux which allows certain binaries or scripts to run at regular intervals, for example, once a minute, once an hour, etc., etc. If we're able to modify a script that is being used for a cron job, or if we're able to modify a component that the cron job or a script uses, then we can potentially escalate our privileges. Okay, so the HackerFrogs AfterSchool network hacking course is done, but tune in next time. We're going to be looking at a new topic, reverse engineering. So we're going to be doing an extra two sessions in network hacking, and we're going to be doing some demonstrations on how to do the network hacking exercises. That's going to be next week, so please stay tuned for that. Okay, let's move on to the next topic. So topic 2 is done, topic 3 is here, and topic 4 is on deck. Okay, so what we're going to be doing for this next topic is we're going to be going over to hackmyvm.eu, and this is another cybersecurity education platform. It's completely free, which means that, yeah, you don't need to pay money to do these exercises. After you've logged into hackmyvm.eu, you can go over to the challenges over in the sidebar here, and we're going to be doing some of the challenges from the cryptography category. So cryptography is one of those important topics for cybersecurity because it allows people to send encrypted messages. So they've got a bunch of different categories here, and let me change up my music and then we can get going. How about some StarCraft? Here we go. Skylar Hawkins says, these workshops are really cool. I have decent experience in Ubuntu, but I never know where to start with networking. This is the perfect place. Yeah, I mean, if you go back about 10 streams in the YouTube, we typically do the HackerFrogs AfterSchool courses in the second hour of the stream. So just skip over to the second hour, and you should be able to see each one of those workshops. There's a bunch of different topics that we covered in the last 10 sessions or so. Okay, so for inside of hackmyvm.eu, we've got a bunch of different challenges in different categories. So there's stuff like OSINT, Priv, crypto, stego, programming, web reversing, Docker, and we're going to be taking a look at crypto today. I'm 2Nobody. Hello, nice to see you here. Welcome in. Okay, so we're going to try to take these challenges chronologically, or sorry, what is the word? Numerically, because well, I have no idea what any of these challenges are because they're just numbered. We're also going to try to do a little write-up, which explains exactly what we're doing for each one of these challenges. So typically, over at HackerFrogs, we have a lot of write-ups. We like to document all the stuff that we do, because if you didn't document it, it didn't happen. So we've got one for each one of the platforms that we use. We're going to be doing HackMyVM, we're going to be doing challenges, and we're going to be doing cryptography today. So I've got one started up for the 0-1 challenge for cryptography. Let's go ahead and get started. Kay, the cyber guy, hello, nice to see you here, Kay. And Thon, hi, hello, nice to see you here as well. Let's give you a fun video redeem. How about some Nyan Cat? Okay, so we're going to do the cryptography challenge here. We'll put 60 minutes in the clock so that we don't spend too long doing these challenges. And let's get started. So if you're logged into hackmyvm.eu, you can follow along with us by using this link. So we'll record the URL for the challenge, the concept for the challenge. I think we're dealing with Base85 encoding in this case, but I could be wrong. Let me take a look. So the challenge simply is this. So this could be any type of encoding or encryption. I'm guessing that it's Base85. So Base85 is a very common type of encoding, and we could probably get the decrypted version of this, or the decoded version of this, with this command right here. So HMV Base85 decoder. So this is the flag, or the goal of the challenge. I'm just going to copy this, and we're going to paste in the flag here. And is it right? You have submitted the flag successfully, which means that was the right flag. Great. Okay, so what we're going to do is we're just going to record the command that was used to solve the challenge over here as part of our documentation. Okay, so method of solve. We look at the string from the challenge, and we guess it's a Base85 encoded string. Okay, so we're just going to include the command over here. So after you complete this, the write-up, after you complete a write-up, we can reference the write-up later if you ever encounter any challenges that use the same kind of technologies. And you can also it's also very important to record the commands that you used to finish the challenge, because if you encounter this kind of problem in the future, you can reference your own documents to use the same commands. Okay, let's move on to the next challenge. So the next challenge is the 04. Okay, so 04, let's click on it. And so we're really dealing with some easy encryption here, or some easy transformation. So this is the next thing. We'll start up our write-up file as well. Let's go ahead and do that. So we're going to make a new file, and this is 04. So we record the URL where we can find the challenge, the concept, and the method of solving the challenge. Okay, so the concept in this case, this is hexadecimal encoding. So let me talk a little bit about this. So hexadecimal encoding. So each letter printed on a computer screen has an encoding. So the typical encoding for computing is UTF-8, and this is derived from ASCII encoding. So ASCII encoding is the typical type of encoding that's used on computer systems, and ASCII can be interpreted So ASCII can be, what is the word? Can be rendered as decimal numbers or hexadecimal numbers. Okay, so for example, the letter A in ASCII can be rendered as, so it's I think it's capital A is 41, so hex 41 in hexadecimal, or let's see, so what is it in decimal? So the other thing about ASCII to hexadecimal format is that there's a big table full of this stuff. So ASCII to, or the ASCII table. Segfaults, hello, nice to see you here. I saw you in Theo's chat earlier today. Hello, nice to see you. Okay, so the ASCII table is here, and it lets you know what numbers are associated with which ASCII characters. So for example, if you got the ASCII letter A, it is hexadecimal 41 or decimal number 65. So this is what we're talking about. So ASCII letter A is 65 in decimal. So if we see a string of numbers and letters like this, these could be individual numbers and letters that have been converted to hexadecimal from ASCII. So for example, 68 is, what is 68? So 68 in hexadecimal is where? .68 in hexadecimal is the letter H. And then next one is 6D. So 6D is M. And then 76 is 76 is V. So the first three letters of this string in hexadecimal to ASCII is HMV. So HMV is like this. So there's an easier way to do this, of course. We can just take the entire string, and then we can go over to a website like Rapid Tables. They've got hex to ASCII. A lot of people were in there. Oh, yeah. So was Pebble wasn't streaming today. He was talking on Theo's stream. So we got hex to ASCII. So in this website here, we can paste in our hex, and then we can convert it to ASCII, and we get this message here, my flag is easy. So we can just copy that, go back to TryHackMe here, and then paste in the flag. Okay. Oh yeah, right. So it's probably more cool to type it into, echo it into XXD. But yeah, let's demonstrate that. Okay, so we've got a minute of ads to do. So I'm just going to take a little water break. We'll be back in about 60 seconds. But in the meantime, check out these birds. Okay, we'll be back in 60 seconds. Just need to do a little bit of water. Okay, so let's put the birds away. I could watch these birds eating peanuts all day. It's just so satisfying to watch animals eat for some reason. Anyways, put the birds away and let's get back to the hacking. So tubred, you can also echo it into XXD. Yeah, for sure. Let's try that. So let me get the flag one more time. Sorry, where are we? Here? Okay, so this is the string. We can copy it. We can go into Linux and we can do it the Linux way, which is inherently cooler. So we're going to echo out this thing and we're going to pipe it into XXD -R-P, and this gets us our result as well. So that's pretty cool. So XXD is going to take the hexadecimal and it's going to convert it back into a printable form from reverse. So reverse it back into a printable form, and we get the same flag as well. That's very cool. Okay, go back to our write-up. So hexadecimal encoding. So when we look at the string, we suspect that it is a hexadecimal string. Hexadecimal strings can sometimes be encoded into ASCII characters. Okay, and then we've got our Linux command over here. And we're done. Okay, let's commit those changes. And if we ever want to do some hexadecimal to ASCII conversion, we can go back to this document and we can remember the commands that we used. So that's very nifty. Okay, let's move on to the next challenge. So the next challenge is going to be number 7. So this is done by a different person, okay, different creator. And wow, we've got some non-standard characters in here. All right, this is going to be a little bit more challenging. So I mean, this kind of reminds me of Base85, but it looks different. It definitely looks different. Let's start the write-up for this. So this is 07, I think it's called. 07. Let me record the URL for this. And the concept, we don't know the concept yet. And we don't know the method of solve for this challenge yet. So this kind of reminds me of like Base85 or Base something something. We could probably try to identify it using CyberChef. So CyberChef is a very common tool that we use in cybersecurity for trying to apply different cryptographic operations, well, cryptographic and like encoding operations. So in this case, we're going to try it out with our funny looking string, and we'll put it in for the input. And we can try something like magic. Magic tries a bunch of different operations on it, and it looks like it's not really giving us too much output. Okay, so we'll just, I don't think magic is the way to go in this case. So there are a bunch of different base encodings. So we got base 32, base 45, base 58. It might be one of these non-standard ones, like Base85. Maybe not. Base64. Oh, okay. So we did Base64 decoding, and we got another string here. So this next string looks like it's been Base64 encoded. So this is, oh, this is just double Base64 encoded. So we render this. Oh, no. This is to base64. Never mind. I want this from. This is from base. So from base85, we'll try this out. So invalid character for base85. Base 64? Nope. Base 58. All right, the other thing we could do is we could try to feed this to our good friend, the AI. So we'll just give it to it here. What kind of encoding / encryption might be represented by this string? Okay, we'll paste it in. We'll see. Looks like backwards base64. They're definitely because there's the equal sign at the beginning. It does look kind of like something reversed. Yeah. Okay, it looks like it could be several types of encoding or obfuscation. Let me analyze the characteristics. Starts with equals 0x. Could indicate hex encoding with a prefix. So contains unusual Unicode characters. So we got Cyrillic characters, Latin characters, and Greek characters. Mix of Latin, Greek, and Cyrillic characters. Possible encodings. Base 13 with Unicode homoglyphs. Okay, this might be upside down or mirror text of Unicode substitution cipher. Okay, so the other thing, the other common tool that we can use in these kind of encryption exercises is decode. So decode.fr. It's a site that is dedicated to encryption and decryption. You can find it over here. And we can get the English version of the site. The site is in French, but we can get the English version. There's a tool on the site called the cipher identifier. So for this cipher identifier, you just need to paste in the ciphertext, and it'll try to make a best guess as to what kind of encryption might be in place. Let's copy that, paste it in. Okay, and then analyze. So it says upside down writing. Upside down writing. So I mean, this might be upside down writing. So decode writes upside down text. So text to flip upside down, we can paste this in, then transform. This looks like man, it still looks like a big mess. So what are some other possibilities we see here? I don't think we see any other distinct possibilities. Let's go back to route 13 with Unicode homoglyphs, most likely. Try mirror writing. Was mirror writing in the list? So mirror writing. Okay, decode text, write text that can be read in a mirror. Okay. Give this a shot. I don't know about this. So image format. Yeah. Let's try what the AI is suggesting over here. So it's talking about route 13 with Unicode homoglyphs. I mean, we could probably find this on so route 13 cipher is here. and they're talking about Unicode. What do we mean by Unicode? Let's see. So the suggestion is ROT13 with Unicode homoglyphs. This might be upside down mirror text or Unicode substitution cipher. So ROT13 yeah, I mean, we could try running the Python code. I don't think it's going to give us anything usable. Okay, then run the code. Yeah, this doesn't... Looks like a base encoding with some sort of number shift or reversed or something. I mean, that's the problem. I prefer challenges that let me know whether or not it's supposed to be difficult or easy. But I guess we would just roll with whatever is going on here. So reverse text, base 64 with Unicode characters. The equals at the beginning suggests base 64, but the characters are unusual. So this would never base 64 decode. Not standard base 64, yeah. This is going to fail because it doesn't have regular base 64 characters. So the characters look like flipped or rotated Latin letters. Convert upside down characters. Okay, so I mean, we could manually take a look at this as well. So what do we got? What do we got? We got this. Whoops. So this is our text right here. So it looks like this could be an SETWEZR. What? What do you think this character is supposed to be? Is this a C? It's not a C because it's backwards. This should be, oh, this is a C, yeah. No. It's an S? It's a lowercase s? It could be a lowercase s. But it doesn't look backwards. It's weird. So M and W are the same. Q becomes P, and then a capital O. Capital M, that is a E. Capital E. Actually, wait, what is this thing? Is this a B? A 3. Yeah, it could be a 3. Yeah, okay, 3. And then this is a backwards K. So I'm guessing it's a lowercase k. And then a 0. A B. An X. A 0. And then an equal sign. Okay, well, I mean, we could try base 64 decoding this and see if anything comes out. Oh, you know what? I think we're getting close. We're pretty close. This looks almost like a flag. So the bread says third letter in the output could be a 1. So it could be a 1. Okay, so yeah, so this fits the HackerFrogs flag format. Let's try submitting this flag and see if it works. Okay, let's just give it a go. Submit flag. Wrong flag. Okay, so we've got some of it right, but the rest of the flag is incorrect. Let's go back to that challenge. This is number 7, right? Let's go back. So this is the number 1. What else could be incorrect? So SE1W, so this is a backwards E. This is, so Z backwards is what, 2? Could this be a 2? What does Z look like backwards? Let me just write this out. Z backwards is a small s, right? Yeah, Z backwards could be a small s. So small s, and then R, and then another small s. So what else could this character be backwards? So it looks kind of like a, maybe it's a capital S. Well, let's try this and see if it looks any different. Okay, I think we adjusted. This is not supposed to be a small s. It's supposed to be a z. Because that fits this this better. Because we do need to have the brackets. So the small s, okay, turns back into a z or z, as you like. Okay, so R is okay, S is well, let's test to see if this one works. Nope, not the correct flag. Okay, we'll go back in. You know what? I think we should reverse this, first of all. So echo this string, and then rev? Yeah, so rev. Let's compare this character by character. So SEWERS. So this might not be, what is a backwards S? So S, backwards S could be the N, the W is all the same. This, I'm pretty confident that this is completely accurate. There's just this character here that we're not really too sure about. So what could it be? So it's a C. Is it a C backwards? C. C backwards doesn't mean anything. If it's an S, S backwards, I think this is the only character we're missing. Okay, we'll try copying this. We'll go over to decode again. So decode has like backwards letters, I think, or reverse letters. Writing in reverse. Is it like mirror writing? Okay, this is another thing where we could potentially give it to the AI. You're out of free messages. Wow, I guess we have to go back to dumb to good old ChatGPT here. We suspect that these letters are supposed to be backwards interpretations. What would the correct letters be? Okay, paste in the thing. So the problem with ChatGPT is that it thinks too much these days. I guess it's supposed to be more accurate because it's taking time to think, but sometimes it just takes way too long to output anything. It does seem to be reasoning this out, which is good. So I'm actually interested. Hey, PwnedLabs, hello Pebble, nice to see you here. Everybody, if you're looking for somebody to watch who is an InfoSec creator and covers a lot of Windows hacking techniques, then Pebble is the way to go. So here's a shout out. Okay, Pebble says taking NCRTP. So you could basically decode every possibility of uncertain characters using shell expansion. I mean, I guess so. We could, yeah, I mean, I'm only uncertain of one character. MCRTP exam. Let me look that up. Cybersecurity. MCRTP. It's a certification. Microsoft Cloud Red Team Professional. Oh, okay, that kind of tracks. Then grep for HMV if that is the flag prefix. I mean, HMV is the flag prefix. The only character we're not sure of is this one. I think every other character we are kind of confident what the character might be. So we just need to substitute this one over here. Okay, let's go back to our good friend the AI. Still not finished, huh? Okay, so we could probably create a script. Maybe Z? Maybe Z? Yeah, I think have we tried that one? Let me give it a go. Well, I'll try submitting the flag. Because why not? Wrong flag. Okay, not the right flag. Okay, so if anybody wants to give this a try themselves, this is it. ChatGPT is taking its sweet time. Weird box. I mean, it's not a box. It's just a cryptography challenge. So in this case, we don't know what this mirrored letter might be. I think what we'll do is we'll just go in here, and we'll write a little. We'll figure out how to write a little script. A G? A G! That's actually kind of, that's an interesting possibility, yeah. Let's try putting a G. This says MA4 May something something. Yeah, I'm not too sure. Okay, so if those characters are meant to be backwards mirrored versions of normal letters, the usual interpretation is to map each stylized Unicode character to its closest plain Latin equivalent. So backwards S becomes forward S. So this looks like a backwards curly S, and sometimes interpreted as C in puzzles, but S is more common intent. So it's either C or S. If your challenge suggests C equals C instead, sometimes they do, the alternative would be this. I mean, we could try both of these. Okay, there's non-standard printable characters in here. Definitely not that. Curly S as opposed to uncurly S. Yeah, that's kind of a funny thing. This looks even weirder. So I mean, I like my stuff better. So a backwards S. So it's either... What if this is... What if this is C? C doesn't really make too much sense either. Ronan, hello, nice to see you here. I see you have a suggestion. Let me grab it and give it a shot. Let's see. HIV. It should. I mean, it should be HMV to match the rest of. So SE lowercase l. I think this should be uppercase I. No? Lowercase l. Number 1. Yeah. I mean, this... Let me try this one. This looks like it makes more sense. Yeah, wasn't it a 1? Yeah, for sure, for sure. I mean, nothing's for sure, but let's submit the flag. Still the wrong flag, but it looks a lot closer. Let's take whatever we have here, and we'll just do our comparison over here. So this stuff is basically for sure. We know this stuff for sure. So the zeros, the M's, these are all... I'm kind of curious why this one was interpreted as a W. Let me just change that one. So the Q... This should be a P, right? 4-letter A to Z, do echo, stuff, letter stuff, base64, done. The letter 5. Wait, where was the letter 5? Sorry, the letter 5. What am I talking about here? The number 5. Inner Peace Hub. Hello, nice to see you here. The number 5. Oh, you know what? It could be the number 5. So this could be the number 5. Well, let's give this one a try. 5 in the place of S. We'll give this a try. Still a wrong flag. Okay, let's maybe we should move on to another challenge, because this is taking up more time than we should be taking up. But I do want... So is that supposed to be reverse Z? That could be an S. Which one? Here? This is supposed to be a reversed Z, which can turn into an S. So the E turns into an E. The Z turns into an... The S turns into like a 2, maybe? Yeah, it could be a 2. O can be lowercase o? Are the flags normally words or random strings? They're usually words, but yeah, I don't know what the words could be in this case. So W is still W, S is still S, E is... This looks like it's a 1, maybe? W remains the same, E, backwards E becomes forwards E. Look, it's looks like it's way off. Yeah. So let's do like a whole new interpretation of this, just so that we can figure out what is for sure. So this is a backwards S. No. This is a backwards S. This is a backwards E. This is a backwards 1? 1 or L? J? J? Maybe. This is a backwards W. This is a backwards lowercase e. This is... This could be an S. So if you flip this around, it looks kind of like an S. This is an R. This is... We don't know what this is. This is an M, W. This is a P. This is a capital O. M, capital... No. Number 3. This is a... What does this backwards K? Is it actually a K, or is it supposed to be something else? So backwards K becomes... Yeah? Is it but is it a small K or is it a large K? SE1 makes HMB though. My font looks different. So yeah, I mean it should be SE1 because it has to encode to HMV. All right, let's put on some more music. Oh, maybe this is supposed to be an excellent... Okay, there are no question marks in Base64 though. So this is probably a K, a 0, a B, an X, a 0, and an equal sign. Okay, so Ronin has a guess. Let's copy that. Paste the thing in. So HMV, 4V, I mean, if this is supposed to be like leet speak, what is it supposed to be? It might be reverse as well. May N 1V4. Oh, no idea. I mean, we can give it a shot. Wow, that worked. Ronin, you are a genius. That was the correct flag. Jesus. I did not like this one very much. Okay, so let's go ahead and talk about what this is. I guess we shouldn't be leaving like flags in our write-ups, but we'll talk about the command that we used. So we actually used this command right here. It was two. It was 2. Yeah. Okay. Okay. Let's take a close look at this thing. Okay. So this is the. It was the number 2. It was basically everything that we were guessing. But this was actually the number 2. Kind of makes sense? Yeah, anyways. Is that the author? Is it? I don't know. Let's check. So this is by... It was created by a person named Bit. Okay, so the concept here is mirrored letters and Base64 encryption. So the method is solve. The string looks like a mirrored version. of a base64 string. When we reverse the string, it looks like this. Okay, so we can try to map each of the mirrored letters to a regular ASCII character. Okay, and there you go. It's Brody. Hello, nice to see you here. What is up? What is up? You know what we haven't done in a while? We haven't done some Jurassic Park.
It's a Unix system. I know this. It's all the files of the whole park. It tells you everything.
Yeah, nice to see you again, Brody. Okay, I think we might try to do one more, although I don't know if we're going to be able to finish it. Okay, let's go back to our cryptography challenges. Crypto. So the next one is going to be 10. Alright, everybody. I will let you have a shot at this first. Been really busy working on the Discord bot, but it's time well spent. Yeah, I mean, it's good to be able to focus in on some projects. Okay, so we'll start the write-up for this, and then we'll try solving it. So this is 10. So the URL of the challenge, the concept, and the method of solving the challenge. Okay, so we've got the URL of the challenge over here. The concept, it looks like some sort of base again. So let's just grab this. We'll go over to CyberChef to see if we can get like a quick win. And we'll just try using magic. Okay, and we'll go into intensive mode. What is HackerFrogs if you don't mind me asking? Yeah, I mean it's another cybersecurity education platform, but it's a bit niche. It's a bit hipster, you might call it. It's kind of similar to, what is it kind of similar to? It's kind of similar to PwnedLabs. So PwnedLabs was a really old, well, it's still a thing. It's a very old site where you can download virtual machines and hack against them. So they've got a bunch of virtual machines that you can download and hack. They also have some lab environments. So this is kind of reminiscent of the PwnedLabs from over the wire. So they've got Venus and they've got Hades, which are Linux labs that are kind of reminiscent of Bandit. And they also have Temperance, which is their own thing. And this is like a programming CTF challenge. It's pretty good. I really like it, and it's also free. So I like to show these indie platforms as much love as I can. Okay, let's figure out how to do this thing. So magic didn't give us anything. So we see that there's a bunch of like non-standard characters in here, which means that it might be like a non-standard like base. It does kind of look like base64, but there are characters that are never going to be. Oh, it could be. What else could this be? So as Brody says, I might spend my Christmas break trying it out and continuing to work on TryHackMe. Yeah, I mean, definitely expose yourself to as many platforms as possible. Don't get married to a platform. it's not the right way to do it. You want to discover what's good about one platform and get the most out of it, and then be able to pick and choose where one platform or another is going to give you unique opportunities. So from Base85, let's try this. Okay. Base85 gives us one part of the string. So this looks like a flag wrapper. This definitely looks like a flag wrapper, but I don't think this is the correct flag. I think what we need to do is we need to take the contents of the flag and then do something else to it. Okay, but just in case, we're going to go over here and we're going to try submitting this flag. Wow, it was just that easy, huh? It's just Base85. That's all right. That was that was a bit simple. It's like Base85. So this looks kind of like Base64 encoding, but it includes special characters that are not part of the B64 character set. So this is Base85. So Base85, let's talk a little bit more about this over at Wikipedia. So it's also called ASCII85. So it's a binary to text encoding developed by this person. By using the first 5 ASCII characters to represent 4 types of binary data, making the encoded size 1/4 larger than usual. Okay. So I wonder why they're using stuff like Base85. Basic need for binary to text encoding comes from the need to communicate arbitrary binary data. Sure. So the characters used by this encoding are basically every special character that you would ever imagine, plus all of the uppercase letters and lowercase letters, and the numbers. Okay, and Ronan says, that is not part. That is not part. And additionally, Z or Z to mark a sequence of 4 0 bytes. So yeah, I mean this is good to be able to identify. So when you see something that what was the actual string? The encoded output would be smaller than Base64. Oh, okay. So I mean I guess that makes sense to use this encoding if like size is a really big factor. So yeah, so the non-standard stuff is this. So these characters over here would never be included in Base64 encoding. So this is what makes me think that it's some sort of something else. And Max, hey, nice to see you here. What is up? Okay, I think we can wrap this up. Can you do Base85 from Base85? No. Base85 is not found. So this is also called ASCII85. I guess you can't really do it from the terminal. I mean, in that case, it's probably like a web app that does the same thing. Base85. I mean, I guess we could just recommend CyberChef. What are we doing? So we're about to start our cloud hacking stuff. Fix what you wrote on GitHub. Oh, sorry about that, Ronan. I didn't notice that. Okay, GitHub. This looks kind of like Base85 Encoding, but includes special characters that are not part of the Base84 character set. This is Base85, which includes all of the special ASCII characters, along with the Base64 set. Okay, we can use CyberChef to decode the message. I was playing CTF Algeria. Oh, Algeria CTF, okay. Got rank 1. Oh, that's great. Yeah, I'm glad to hear that, Max. Thank you. Okay, let's go ahead and commit these changes, and we can move on to the last part of today's stream. So the last part of today's stream, we're going to be doing some free challenges over at PwnedLabs. So PwnedLabs.io. It's we're actually trying this for the first time. So Henry Babyllion says, "Hi, I'm from Algeria." So yeah, so maybe Shulk, Wisek, and Henry, maybe you can start talking about security stuff. I don't want to be famous. No worries. Okay, so PwnedLabs is it's a very, well, we'll see what kind of platform it is. I've heard good stuff about it, and I heard that PwnedLabs was created by someone who used to be part of the Hackbox team. So you can make an account there for free, and yeah, you can do the same labs that we're doing. So we're going to be trying to do these cloud labs. So cloud, we're dealing with AWS, and it's called Breach in the Cloud. Let's try creating a walkthrough for this. Okay, walkthroughs, PwnedLabs. AWS Labs. And I think this challenge is called Breach in the Cloud. Okay, so we'll be recording all of our usual stuff here. Okay, so Breach in the Cloud, we need to get our URL, our concept. Well, so this is cloud hacking stuff. So we turned on the lab and check the description to start pwning. Okay, so where's the description? Where's the description? Okay, I think I need to reload the page. Yeah, where's the description for the? Click on the lab button. Of the, is this it? Or is this one it? Oh, the lab is off. Okay, I need to turn the lab on. Okay, so the lab is on, great. And so we've got a VPN file. I think I've already downloaded this. So AWS credentials, we have these AWS credentials that we need to copy. And we need to configure our AWS CLI tool. The slider in the top right. Yeah. I found it. Thank you very much for letting me know about that. 6364. Thank you. I hate cloud challenges. Well, I mean, we need to educate ourselves. We need to get better at these things. So we got our access key and our secret access key. We can just copy this, and then we can go over to our terminals. We'll call this terminal AWS CLI. Okay, and so we would typically run AWS configure. Oh, okay, never mind. when we run configure, we need to give a profile name. So we'll call this profile lab01. Okay, so we need to provide an AWS access key. We paste it in, and then we need to give the secret access key. So all of these are over here, which we can just copy. Okay, and we need a default region name. So let's see, Max says, I have some DevOps with AWS CLI. I mean, I'm thinking that a lot of people who do development, cloud development stuff, they are already familiar with AWS CLI. So the default region name, we don't have one, so I think we're just going to default to US East 1. Default output is going to be in JSON format. So we can just keep that. And then we can start the challenge. So also suitable for a CTF approach. So what is the scenario? So we've been alerted to a potential security incident. The huge logistics security team have provided you with an AWS key for an account that saw unusual activity, as well as the AWS CloudTrail logs around the time of the activity. We need your expertise to confirm the breach by analyzing the CloudTrail logs, identifying the compromised AWS service, and any data that was exfiltrated. So lab prerequisites: basic Linux command line knowledge, learning outcomes, prettifying JSON files for easy analysis, familiarity with AWS CLI, familiarity with analyzing CloudTrail logs, enumerating S3 buckets, and simulating an attacker to validate the path to breach. So, I mean, I've done a little bit of enumeration of S3 buckets. I've never really dealt with CloudTrails, so this is going to be some new stuff for me. Okay, difficulty beginner. Focus blue, so this is more of a defensive cybersecurity challenge. So real-world context. Analyzing AWS CloudTrail logs is a standard practice for detecting suspicious activity within an AWS account, while S3 buckets are frequently targeted by attackers due to the valuable data that they contain. Okay, so to get started, download the CloudTrail logs in this zip file from the cases file in the PwnedLabs Discord. So we need to go to the Discord. You need to be logged into Discord before clicking on the link. Oh, okay. So I guess we need to join the Discord. Let me go ahead and do that. Do we need to be logged into Discord on our Kali machine? It seems a bit a bit excessive. But I guess I can join their Discord, sure. I think that's just the write-up. I mean, the thing is that we need this document to do the challenge, because we need to look at the CloudTrail logs. Okay, let me give it a go. So first I'll join the Discord. Okay, so I think... What does the PwnedLabs Discord look like? What's the icon? Yeah, I'm trying to join it, but I don't see it. So the other thing is that is there anything else that we actually need to I'm pretty sure we need this file. PwnedLab discord.gg PwnedLabs. Okay, let me copy that. Okay, I've joined the Discord. Now I need to go over to the cases files channel. Okay. I think I see it, and then I need to download the file. Okay, I've downloaded the file, and now I need to move it over to my Kali box. I'm gonna move it over via email. So I'm just gonna email the file to myself. Just a second, everybody. It's going to take a little bit of time for me to send the email. Okay, so the next thing I need to do is I need to download the thing in my email on my Kali box. I'm just going to do this off screen, so I don't expose any of my email stuff. Just a second, everybody. Are we on cloud hacking now? Yeah, we're doing the cloud hacking. Let me change my overlays. Just a second. Okay, so I've downloaded the file, so I can just get out of my email now. All right, we can go back. Sorry, everybody, I needed to do some OPSEC stuff. All right, so we've got the file in. We'll just put it in our text editor over here. So we'll move. So from the downloads file, I think it's called incident something. Incident something something. Okay. Okay, and then we can unzip the file. So there's a bunch of JSON files here. Which one do we look at first? There's probably like a specialized program that we can use to look at this, but I don't know what it is. So I think we're gonna press the learning button. We'll be following. You talking about PwnedLabs? Yeah, it seems really cool. Yeah, for sure. So the guide uses Linux, but it's possible to complete the activity using any operating system. So we unzip the stuff, we get all the JSON files, and so we're taking a look at this stuff inside of JQ. So JQ is a JSON parsing program, I think. So open the file in text editor will reveal that the JSON files aren't prettified, which makes them hard to read. So to prettify the files, we can use JQ. So a command line JSON processor. I'm pretty sure we have it installed JQ, but it's not installed on Kali Linux by default. So for file in star.json, do JQ. So opening the file in Nano, the data is now much easier to read and scan. All right, well, we'll give it a try. Oh wait, we don't even need to do a script. We can just run the command, right? Okay, so we ran JQ on each one of these, so we should be able to just look at them normally now. Okay. So what are we supposed to understand here? There's 4 of these. How many of these files are there? 1, 2, 3, 4, 5, 6, 7. So there's 7 of these log files to look through. Let's try looking at them one by one to see if there's anything like super unusual here. The thing is that I don't do very much blue team stuff, especially not blue team stuff that has to do with like AWS. So I'm gonna have to treat this as like a learning experience. This is something that's pretty foreign to me. So I'm wondering if there's like a special like web interface that is a lot easier for looking at these log files. So something like Splunk, or because I'm really not sure what I'm looking at here. How long is this? So this log in particular, it's pretty hefty. Okay, dead silence. Nice to see you here. What is up? We're doing some forensic stuff. Apparently we're doing AWS forensics, which I didn't really anticipate. Maybe we should be switching over to a challenge that is more like offensive related, and I might feel a little bit more at home. Because it feels like I'm gonna have to do a lot of learning in this case. So grep our username, sort u. Open the file in Nano. The data is much easier to scan. Yeah, true. So learn what AWS principals, IAM users and roles have been generating activity in the captured logs. So grep our username, sort by unique. So we got temp user, Devan SH, Ian, policy user, temp user, admin role. So this reveals that the suspicious username temp user doesn't match. Okay, so I think what we want to do is we want to switch over to a lab that is more offensive related, because I am interested in learning more about forensics, but in this case we should try something that is a little bit more proactive, and because I prefer doing like offensive security stuff. So let's go back to let's look for another lab to do. So inside of PwnedLabs, let's stop the active lab and we'll go back to the beginning here. So we can look for, let's do red team. So red team AWS free. Okay, identify the AWS account ID from the public S3 bucket. So this seems a little bit more, this should be red team oriented because we did our filtering. Okay, identify the AWS account ID from the public S3 bucket. We'll turn this lab on. If anybody's wondering which lab we're doing this one. Okay, so AWS credentials and IP address. Okay, good. So the IP address we need to reference is over here, and we need to download a VPN file to access this IP address, because I'm pretty sure this is on their private network. So we'll download the VPN file, and yeah, so let's go ahead and activate the VPN. So we'll call this tab Open VPN Access. And let me get my music started again. How about some Dungeon of the Endless? Okay, so let's just identify the AWS account ID from the public S3 bucket.openVPN. That's a mouthful, but I guess we can use this. So sudo openvpn this thing. Okay, so now we should be connected, and we should be able to access the lab. So the lab is on. This is the IP address. So let's see if we can access this from our web browser. HTTP, this thing. Okay, so we've got a website over here. Nice. Okay, let's, so the lab is called Identify the AWS account ID from the public S3 bucket. So we've got our access ID key and the secret access ID key as well. So we're just going to copy these and we're going to configure our AWS CLI. So AWS configure, we'll still just call this lab 1. We'll just copy over the other stuff. So this is our key and the secret access is this. So the region name, let's still do US East 1, because we don't especially know which region we're dealing with. And the default output format is none is okay. That's going to be in JSON format. Dev D says, do you code often? I wouldn't say I code often, but every once in a while I do some coding challenges in Python. I think we're gonna be coding next week. Just in case you don't know, we publish our schedules every week over at HackerFrogs at the HackerFrogs subreddit, and this is the last week of 2025. Next week, we're gonna be doing Advent of Code. We're going to be doing Advent of Code next Friday. But we've got a lot of good stuff next week. If you're interested, take a look at the schedule over here. Okay, so what we were doing, S3 buckets. So the first thing we want to do in any of these cloud hacking challenges for AWS, I wrote up a little guide, well, not a guide, but notes for myself. Let me take a look at my notes. So HackerFrogs, I'm writing up a little, some notes for cloud hacking. So startup, what do we do for startup? So installing AWS CLI, we've done that. We configure our account. And the next step is to do our starting enumeration. So get user info, so STS get caller identity. So this will let us know what our username is and some other details. So let me copy that. Okay, so our username is S3 user. The account number, the account is over here, and the user ID is this. Okay, so the next thing we can do is we can enumerate the S3 buckets. Let's figure out how to do that. So enumerating S3 buckets. So S3 buckets are file repositories in AWS. We can use this command to list them. So AWS S3 API list buckets. So whenever we give this command, we should provide our profile as well, because I've got a bunch of different profiles. If you don't do this, you might run into some problems. So we're not allowed to do the list all my buckets action. So we could also try S3 LS to try to list out the buckets. Okay, so we can't do any of this stuff. All right. So what other starting enumeration stuff should we do? So get user info, and then we tried enumerating the S3 buckets. That didn't really work. The other thing that we should be doing is we should be getting our own permissions. So we would do AWS IAM list attached group, well, not group policies. We want to do attached user policies. So the user policies command is this one over here. So our username is, I think it was like S3 user. Hold on, let me double check my user's username. So S3 user, so user is S3 user. So list attached user policies, username S3 user. Oh, I forgot to include the profile name. So profile lab1. S3 user has no identity-based policy, so I can't get those policies for this user. Yeah, so let's see. What should we do next? So the lab specifically is called Identify the AWS account ID from the public S3 bucket. So we don't know what the S3 bucket is, but I think we might be able to from looking at the website. And Ram31, hello, nice to see you here. What is up? So Mega Big Tech. The other thing we should be looking at is we should be looking at the lab details, because it says not suitable for a CTF approach. Okay. So the scenario. So the ability to expose and leverage even the smallest oversights is a coveted skill. A global logistics company has reached out to your cybersecurity company for assistance and has provided the IP address of their website. Try LS again with the profile. Yeah, that might be a good idea, Ronan. Let me give that a try. So LS. Yeah, we gave the profile last time. We also did the profile when we tried these two. So yeah, that's not the... I don't think that's the issue in this case. But we should probably read the challenge description. Your objective, start the engagement and use this IP address to identify their AWS account ID via public S3 bucket so that we can commence the process of enumeration. So learning outcomes, knowledge of a technique that can be used to find AWS account IDs, understanding what a tool does by performing a code review. Okay, difficulty foundational, focus on red. So let's see, real world context. So we're not gonna follow the walkthrough unless we really get stuck. But in the real world context, we got this. If threat actors get their hands on an AWS account ID, they can identify the IAM roles and users tied to that account. They can do this by taking advantage of detailed error messages that AWS services return when inputting an incorrect username or role name. These messages can verify if an IAM user or role exists, which can help threat actors compile a list of possible targets in the AWS account. It's also possible to filter public EBS and RDS snapshots by the AWS account ID that owns it. Okay, let's give this a try. So I'm guessing that the images are going to be hosted on an S3 bucket. So I'm just going to go over to open this in a new tab. Okay, so this is the address over here. So the file address we get for this is megabigtech.s3.amazonaws.com images workpro1.jpg. So this is hosted on an S3 bucket. So what we need to do is we need to enumerate this S3 bucket. So I think I've done this before, but I don't really remember. Let me take a look at some other I'm pretty sure I recorded this in my GitHub. The last time I saw something like this was in Advent of Cyber for Hack the Box, for TryHackMe in another year. So TryHackMe, Advent of Cyber, yeah, 2021. So this one, Cloud Elf Leaks. So the image indicates an S3 bucket associated with it. So we saw something like this. This lets us know that the bucket name is this thing. So in our case, the bucket name is hold on. So this is the thing. The format is slightly different. So this is HTTPS. Ah, okay. So we might be able to S3 So we can use the, let's see, AWS CLI command to check if the S3 bucket has open permissions. So S3 ls, and then we check the particular S3 bucket. So in this case, we go back here. So S3 and then the name of the bucket. So the name of the bucket is Mega Big Tech. Or at least that's my best guess. Go back here. Mega Big Tech doesn't seem... Well, maybe we can just... Can I just grab this? The specified bucket does not exist. Okay, so is this not a bucket? Oh, yeah. So the other thing we could do is we could just directly navigate to this directory. Sorry, we can just hard navigate to here. So this gives us an access denied. So we got a request ID, we got our host ID. And this tells us that we're not able to directly list this. Not this directory, but can we go directly to this? Ah, okay. So this actually does let us list out everything that's in this that's in the bucket. Try the Mega Big Tech. So is it just Mega Big Tech? Okay, so we are able to get the list of files. Okay, this is, I mean, this is good. This is recursive no sign request. But I guess we could use our own profile as well. So instead of recursive, instead of no sign request, we could do profile lab01 instead. Oh, wow. S3 user is not allowed to perform this. So if we we can't do it if we're using a profile, but if we do it with no profile, then we can see it. That's kind of odd. You have the second line, you have the name in the second line in Firefox. So, okay, Firefox, okay, so the bucket name is Mega Big Tech. Okay, cool. All right, so what are we looking for? We're looking for... identify the AWS account ID. So the account ID, it's not in this output though, right? We have been able to enumerate the bucket. Okay, and we got our keys, we got our file paths. This doesn't let us know any like secret information though. Okay, and we can navigate directly to this by just pasting this into the web browser. So yeah. Okay, so what happens if we give something that does not exist? Test. Okay, so no such key, the specified key does not exist. Request ID, host ID is this. This isn't leaking any like super sensitive information, I don't think. Okay, so what else can we do? So we took a look at the bucket here. So sometimes, can you upload to the bucket? That's a good idea. AWS S3 upload command. So AWS S3 CP local file path, bucket name destination key, bucket name destination key. Oh. Sometimes there's anonymous upload. Panakapanko, oh boy, not AWS. Well, I mean, we're trying to get better at this stuff. Okay, we'll try creating a test file. So echo to test.txt. So we'll call it HackerFrogs like and subscribe. Okay, and we'll try to upload this using the AWS CLI command. Okay, so local file path is /test S3 bucket name destination key. So we're just naming this, right? I think we can just... So the bucket name for this bucket is Mega Big Tech. Let's see if this works. So we probably need to put some other parameters on the end of this, right? And let's just try this. So upload failed, access denied. So when calling the put object operation, access denied. So we can't do arbitrary upload, which is good from a security standpoint, but a bit disappointing for us, you know, hacker people. Okay, upload a local folder recursively, sync a local directory, upload to a specific path. Okay. And Hassie, hello, nice to see you here, and thank you very much for following PTZ, thank you. Or PTZ. All right, let's, you know what? We need to remind ourselves what we're doing here.
Hack the planet! Hack the planet! Shut up and get
Oh, you know what I haven't done? I haven't set my timer up. So we'll go for another 90 minutes. So let me set my counter, my timer, my countdown timer. Let's do that. Okay, so I think we'll, not exactly sure how we're going to be getting this thing. The goal is to identify the AWS account ID from the public S3 bucket. So what do they mention here? Use the IP address to identify the AWS account ID via the public S3 bucket so that we can commence the process of enumeration. Knowledge of a technique that can be used to find AWS account IDs. So we're trying to, were we trying to take over AWS? I don't think we're trying to take over AWS in this case. We're trying to leak information. Okay, so they can do this by taking advantage of detailed error messages that AWS services return when inputting an incorrect username or role name. So we're talking about usernames and role names. These messages can verify if an IAM user or role exists. Okay, so we'll just follow the walkthrough for a little bit. If you want to attempt this technique without reading the walkthrough, feel free. The IAM credentials you need are included in the entry point section, and the role you can assume is named this. Oh, okay. So I guess what we need to do is we need to... I guess they also mentioned that we can take a look at the, we can nmap the IP address. I mean, okay, so the IP address is here, and we can nmap this. Let's do this for fun. Just for fun. Okay. Nmap the thing. So I'm pretty sure, we weren't able to access it. Wait, my VPN is up, right? PN, oh, true. So we're stealthy, we're stealthily scanning it. We discovered port 80 because, well, this server is not responding to ping scans. I mean, I'm pretty sure we're only going to be able to find port 80 open on this thing, but we'll come back here later to see if we manage to find anything else. Okay, so they said something about the role, right? So we also need to do some enumeration about our user. Let me see if it's in my notes. So user permissions. This command lets you know what permissions that you have. General policies. I'm pretty sure this came back not great. So IAM get attached user policies for us, and we weren't able to do it. So let's see. The other thing that we can do is we can get the list roles. So AWS IAM list roles. You know what? This makes me feel like I don't have my AWS stuff configured correctly. Thanto, hello, nice to see you here. Let's see, Hassie says, why don't we search for files and directories? I mean, I don't think... We're doing cloud hacking right now, and we're trying to figure out what exactly is our configurations are for this account. Hold on, let me make a whole new profile for this, instead of using another one. So we'll call the profile PwnedLabs 01. How about Pwn01? Okay, so we need to do the access key, all that other good stuff. Let me grab that stuff real quick. So the access key is here. And the secret access key is here. The default region name, we'll just do US East 1. Okay, AWS STS get caller identity, profile Pwn01. So we are the S3 user. That's our name. So let's do the other stuff. So IAM list roles. We can't do this. It seems like we're very limited. We're very limited in our ability from this user account. Okay, so list roles. We can do group enumeration, so list groups. So I know Paku has a module to brute force roles. Yeah, I think we might have to do that. I mean, I installed Paku just like yesterday. So Paku is a tool that can be used for AWS hacking stuff. Okay. So list user policies for our name. So we don't have any user policies. So the lab itself, it gives us a role. What was it? So the IAM credentials, user credentials needed are in the entry point section, and the role that you can assume is named this. Oh, well, I mean, if we're given a role that we can assume, then maybe we should just assume this role. Okay, so AWS assume role. So what is the command to assume the role? And Blitz Motivation has just subscribed on YouTube. Thank you very much for the subscription, Blitz Motivation. Thank you. Okay, so you need to configure the target role profile, add a new profile to your AWS config file by specifying the role ARN and the source profile to use it for authentication. I didn't think it would be this... I would think it would be this complicated, but... Okay, So AWS CLI method is here. Configure source credentials. Ensure that you have a working IAM user profile with permissions to call on the target role's ARN. So configure the source credentials. Configure the target role profile. Add a new profile to your AWS config file specifying the role ARN and the source profile to use for authentication. So I'm assuming that we're going to have to edit this in Kali Linux. Rajesh, hello, nice to see you here, and welcome to the stream. Thank you very much for subscribing on YouTube. So what is the directory called again? .aws. And thank you very much for subscribing on YouTube, Zenny. Thank you very much. Okay, so we got config and we got credentials. So we can go into the config file and then we can start reading those things. Config. I guess we can edit it with nano. Okay, so what are we doing in here? So profile, region, output, role ARN. So I guess we can copy this. So source profile, I don't think we have one. So we're currently using the Pwn01. So role ARN is going to be equal to this thing that they give us over here. Okay, we'll go back and just paste this in. And do we need anything else for the config? Output JSON, role ARN, source profile. Profile with user that can assume role. So profile with user that can assume role. Role session name equals my session. Source profile. Do we need this? Maybe we don't need to add all this information. So we'll just save this and then we'll try running some commands. Partial credentials found in assume role, missing source profile or credential source. So we need source profile, and we need either source profile or credential source. So how do we identify the source profile? Profile with user. Let's go back. So is the source profile this one over here? So is it an account number or is it a user ID? Okay, let's see. Assume role, source profile. So the source profile is a setting in the shared configuration file, okay? How to configure source profile. So you define an assumed role configuration using your profile, okay? The source profile is the one containing the initial credentials used for the assume role API call. So maybe we can just put source profile default. And thank you very much for subscribing on YouTube. Nyok Kwa Hui? I'm not too sure how to pronounce that name. But I'm pretty sure it's a Vietnamese name. But thank you very much for subscribing on YouTube. Okay, I think it is what you named the profile of who you want to assume the role as. So can we just use default source profile? We'll give it a try. That's funny. It's trying to... Oh, okay. Profile is going to be pwn01, not... Yeah, okay. Right. Let's get back to it. So this isn't... So assumed role is not authorized to perform this action. Okay, so we can't do this. Can we do some other actions? So list users. We can't use the list users action. Okay. Can we do the S3 stuff? S3 LS? My guess is there's more perms with the bucket because the role name is leaky bucket. So the S3 API. What was that command called again? S3 API list buckets. Okay. And Saki, hello, nice to see you here. Do you have knowledge about electronics? I'm not really much of a a hardware person. I'm more of a software person. So not very knowledgeable about electronics, unfortunately. Okay, so no identity-based policy allows the S3 bucket list all my buckets action. So we can't do this. How about we try something? So I am, was it get list policies or something like that? So list roles didn't work, list users didn't work. List attached group, no wait. List attached user policies. Actually, STS... STS get caller identity. So I'm pretty sure our username really hasn't changed. Or has it? Will AI replace programmers and ethical hackers in the future? Will AI replace programmers and ethical hackers in the future? I think AI will replace realistically, AI is probably going to replace like a large portion of the population, of the market, I guess, of programmers and ethical hackers. There's still gonna be people working in the industry because you still need somebody to know what exactly the AI is getting up to, because otherwise you're just relying on the AI to police itself, which is a really bad thing. Okay, so our user, we have an ARN, but we don't have a username. Maybe Botokor session is the name of our user. Hold on. So leaky bucket is, I'm assuming that this part is the username. So Botokor session something something. Okay, and Let's try... Let's try this. There's no identity-based policy that allows the IAM for list attached user policies action. Okay, so we can't... So ARN is not authorized to perform this action, so we can't do this. And Zenny, hello, nice to see you here. I'm here for the TryHackMe content, recently subscribed for a year. Got my software engineer degree a week ago, and will start in cybersecurity. Let's see, Pebble says I would try to brute which actions you can run now with the new role. Not too sure though. Let's see. Microsoft cloud skills are much better than AWS. I mean, that makes a lot of sense because you deal a lot more with Microsoft stuff, Pebble. Yeah. But we'll try Paku. Actually, I shouldn't do it from here. Hold on. Let's get out of here. Paku is a tool that can be used for AWS security stuff. We'll start it up over here. Okay, so new session. We'll do a new session. What would you like to name this new session? Leaky Bucket. Okay, no key set. So we can import stuff from here, right? Uh-oh. Why does this look so jank? Okay, import keys, profile name, something something, right? So import keys, profile name. Import keys, Pwn01. And Leon, nice to see you here, Leon. Nice to see you, thank you. And Saki says, is data structures and algorithms required in hacking? Data structures and algorithms? Not usually. Not usually. It really depends on what you're hacking. What do you want to be hacking, first of all, is the question. Saki asks, how many programming languages do I need to learn to become a good ethical hacker? It really depends. It really depends. Let's talk a little bit more about this, you know, because a lot of people ask about this. What programming languages? So most people who get into ethical hacking stuff, they learn Python. For people who go into basically like any general role, Python is very, very popular. If you're doing like low-level stuff like C and assembly, this is going to be required to go into like low-level roles. So low-level roles, we're talking about, I don't know, reverse engineering, malware researchers. Santer says, hack the world, hack the world. Yeah, let's do it.
Hack the planet! Hack the planet!
Okay, Blue Dream says, first time catching you in live stream due to time zones. No worries, no worries. You must live somewhere in Asia, Blue Dream, because it's hard for people in Asia to catch my live streams. So C and ASM, if you're dealing with web app stuff, you'd probably want to learn like PHP, maybe JavaScript, SQL stuff. That's for your web app hacking roles. It really depends. Let's see. Ronan says, is this Cloud Breach S3 Lab? Cloud Breach. Panakopanko says also Europe. Panakopanko, are you still here? Are you getting enough sleep? I'm very concerned about your sleep schedule. Okay, so PHP, JS, SQL stuff, this would be your web app hacking roles. Generally, the further you go into ethical hacking, the more programming you're going to have to learn to advance. So initially, most roles don't really require you to do very much programming. But you'll find that if you don't know how to do programming and write your own tools and stuff like that, you're going to bump up into a glass ceiling. So Zenny, just going for SOC analyst though. Oh, I mean, if you're just being a SOC analyst, you can probably just get away with some basic Python knowledge, because people in SOC analyst roles, they're not running a lot of the code aside from like automation stuff, and in that case, Python is going to be your go-to language. Okay, let's continue on. So what were you doing? We're trying to use Paku. So Paku, okay, so leaky bucket, and Pebble suggested I would try to brute force which actions you can run now with the new role. So Paku action brute force. Okay, Ashen Corridor. Hello, nice to see you here. I'm new here. I got your live stream in my YouTube homepage. Well, I guess the YouTube algorithm is doing what it's supposed to do. But welcome in, Ashen Corridor. Nice to see you here. Okay, so Paku key brute force methods. IAM brute force permissions. This module attempts to brute force all possible IAM permissions associated with the current user's credentials to discover which actions are allowed. This sounds like a good time. Okay, let's try that. I think it's like this run. No, we need to run from down here. This is getting in the way. Okay. Okay. This is a lot of output. Hopefully it gives me like a summary or something after it's finished. Otherwise, yeah. Okay, I'm just gonna wait for this to finish. Love your channel vibe. Thank you very much. Okay, so what else can we do? I guess another thing we can do is we can figure out what we can do from the S3 API. So we can do copy bucket, create session, delete bucket. Okay, just to get me on the right path, we're going to follow the walkthrough for a little bit. Okay, so enumeration, we scan the thing with nmap. I think we've finished with our nmap scan here. So we've only discovered port 80. Okay, so mega big tech, there doesn't seem to be any interesting functionality. Let's check the source code. So I guess we could also discover the name of the bucket by looking at the source code. I mean, we discovered the name of the bucket by taking a look at the resources. So inspection of this bucket in the browser, the images directory with other images, but nothing too interesting. So we managed to find the repository in the S3 bucket of all the images. So the S3 bucket name, you can get the ID of the AWS account that it's hosted in, really. Okay? It's possible to quickly brute force the AWS account ID in an S3 bucket. I'm interested in learning about this. So reading this research post and also reviewing the code here is recommended, but a TLDR is that this script creates a policy that utilizes the S3 resource account policy condition key to evaluate whether to grant us access to an S3 bucket based on the AWS account. The script doesn't have to guess a trillion different account IDs. The available search space is massively reduced by leveraging string matching and wildcards. Each correctly matched digit is appended to a variable, and the request is repeated until the account ID is found. So Santer says, can the bucket URL be encoded in the source code, or does it have to be plain text? I mean, I think we'll just keep on reading over here. So we have provided a user with with a role that it can assume to carry out this attack. If you do not have access to an AWS account, oh, okay. If you'd like to set up your own user and role yourself, you can create the policies below. We have to create policies. When setting up your own offensive infrastructure, you need to create the user, create the role with this trust policy that allows your user to assume it, and then attach the policy to my role that allows querying the S3 bucket. Okay, so we need to create a user, create an IAM user in your own AWS account. The IAM user, assuming the role, would have the following policy attached. The inline policy is also okay. So we've got, so the user is this. Where do we save this? We need to save this in a file somewhere, right? So resource, your AWS account ID, your role name. Then create the role. So the role that PwnedLabs provides has a policy attached that allows S3 get object and S3 list bucket permissions to the mega big tech bucket only. This is to ensure that our assistants aren't used to enumerate resources outside the scope of the lab. You can create and attach the policy below that allows performing the attack on any S3 bucket that you are authorized to access. Okay, so the role you create would also have the following trust policy configured, allowing your user to assume the role. So do we need to do this from some sort of web app, or can we just create like a local file? So for the rest of the lab guide, will be using the existing user provided by PwnedLabs. First, let's set the provided credentials using AWS configure. This allows us to execute commands in the context of the user that can assume a role that we've assigned the S3 get object and S3 list bucket permissions. Assuming a role that's assigned one of these permissions is required for the script to work. Okay, so they run AWS configure. Yeah, so this is exactly what we did. Comrade Soul, hello, nice to see you here. What is up? And you know what? Let's give you a fun video redeem. How about some Devil's Bedroom?
Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the Devil's Bedroom. Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the Devil's Bedroom.
Okay, so they create the configuration. We've done this already. Go ahead and use the command python3 pip install S3 account search to install the tool S3 account search. Okay, I guess we need to. Let's do this in a Python virtual environment, because I don't. Python environment. Okay, I need to figure out how to activate the virtual environment every time. So it's Python -mvenv, and then virtual environment, and then source bin activate. Okay, so we're now in our virtual environment instead of Python, and we can install this tool. So the tool they want us to install is called S3 account search. So let's go ahead and do that. Okay, so excuse me, everybody. I just need to switch on my music again. Just a sec. How about we play some XCOM music? Okay, so we've got the tool in here. Neems, hello, nice to see you here. What is up? What is up? Okay, and what do they want us to do? So you may need to run the following commands to add the binary location to your path. Do we need to? If you're using a different shell, be sure to modify the appropriate configuration file. Next, we need to provide the Amazon resource name, the ARN, the schedule. We're doing cloud hacking stuff. We're currently doing this lab over at PwnedLabs.io. And yeah, I'm learning a lot of new stuff. So next we need to provide the, provide the Amazon resource name of the role under our control. For example, in our own AWS account, as well as the target S3 bucket of the AWS account, whose ID that we want to enumerate. Here we've created the role and provided it to you. Okay, so this is it. So S3 search account, ARN. I mean, we can just copy this entire thing. Okay, and we'll try doing this in the Python environment here. Okay, so so it's using the wrong thing. So search account, we need to provide the profile, I think. How do we set our default? How do we set our default profile? Just a second, I need to figure out how to do that. So AWS CLI set default profile. So export AWS profile equals your profile name. Okay. So this is this in my environment variables? Should be near the top, right? Well, I guess it's not here. I guess we need to set it. So export AWS profile equals your profile name. Okay, and we'll try running it again. Okay, running this thing again. So this is still... This is still giving us errors. So they, I think, they recommended something up above here, right? You may need to run the commands below to add the binary location to your path. So export path, source, so echo export path equals path and local bin to bashrc. And then source bashrc. If you're using a different shell, be sure to modify the appropriate configuration file. So for example, ZSHRC for ZSH users. Ah, okay. I mean, we are using ZSH in Linux, in Kali Linux here. Okay, so ZSHRC. Okay, and the second command was this one. And Nux, thank you very much for subscribing on YouTube. Much appreciated. Okay, and then let's see if we can run this command now. We're still getting errors here. So S3 Search Account is the tool, and we installed it. We installed it using using pip install. Okay, so the ARN for the role, it was provided to us up at the top here, I think. I just want to make sure that this stuff matches. Yeah, so this is the exact role. Let's see, Himan Chu, hello, nice to see you here. After learning all the networking, then the OS, what should I do next? Please recommend in brief. Hello, Himanshu. Nice to see you here. So after learning all the networking, I mean, Himanshu, can you remind me again what kind of role that you're aiming for in cybersecurity? If I know what the goal is, then I can give you some advice. Okay, so I'm getting some error messages. An error occurred, access denied. Okay. So I think the problem here general. There's no general role in cybersecurity. You need to be specific about what kind of job you're trying to work towards. Okay, so what did they say up here? So create the user. Create an IAM user in your own AWS account. The IAM user, assuming the role, would have the following policy attached. How do we create a user in our AWS account? So I mean, do we need to have like a personal AWS account to do this? Or can we just, red teaming. So red teaming role is more, that's a little bit easier for me to understand. Santer says you can have a general role in small companies with limited IT staff where you can wear multiple hats. A good place to find the right path. I mean, I don't know if that's super helpful to somebody who's getting their... I understand how you say that when you work in cybersecurity in like a really small company, you usually have to do like everything. The thing is that when you're training, when you're doing your education, you probably want to specialize towards like a very specific role. I mean, if we're talking about pen testing stuff, and Himanshu, it sounds like you're trying to steer in that direction. let me give you some education resources. So what I want you to do after you complete the networking stuff is take a look at the network hacking education resources over here. Another thing you could try is you could try looking at the web app hacking resources as well. Because usually when you're talking about red teaming stuff, it's usually going to be network in general or web app specifically. Okay, so in this case, they want us to create an IAM user. AWS create IAM user. Okay, so you can create an AWS IAM via the AWS Management Console, the AWS CLI, or the AWS API. So if we can just do it via the CLI, that would be good, because that would take a lot less time. So you can also create a user using the command interface with AWS IAM create user command. First ensure that AWS CLI is installed. Okay. Run the command replacing my user with the desired name. So, okay, let's give this a shot. So in this case, we'll call our user leaky user. Okay, so we can't create the user. I guess we're using the wrong profile or something. Okay, to grant permissions, you typically add the user's group and attach a policy. Avoid using the root user for daily tasks. Okay. Alright, so I think we can skip this. The role that PwnedLabs provides has a policy attached that allows this. The role you would create will also have the following trust policy configured. Yeah. We did this stuff already, and when we run this command, get caller identity, it should say that we're the S3 user. Let's try that out. AWS STS. What was it called? Get caller identity. So yeah. So we got an ARN associated with this. Maybe we should get rid of the ARN, because that might be getting in the way. So we'll get rid of the role ARN here. And we'll try running the script again. Okay, now it works. Now it works. So the problem was that the username wasn't coming out properly. Okay, so the script, so this tool is being used to get the name of the account, right? Okay. So we run the tool, and this reveals the AWS account ID, which is this. Okay, we can use this information to hunt down public resources that might have been accidentally exposed by the account user, such as the public EBS and RDS snapshots. So first, it would be good to know that the AWS region that the S3 bucket was created in, as public snapshots are available to all users in the same region that the EBS and RDS snapshots are created in. So it's likely that if an S3 bucket was created in a specific region, then other resources will be available there too. Okay, to find the S3 bucket region where we can use another trick, this time with curl. So we curl the bucket, yeah, and what are we, oh, is this revealed in the headers? So there's some secrets in the headers here. Let's give this a try. So the tool is running in the background. It finished, and it gave us this account number. Okay, and let's try running this curl command here. So there's X Amazon ID, and so the bucket ARN is this over here. So what do we? Oh, the region. So we actually get the region from the headers here. Okay, how do I make a script with any language? How to make a script with any language that you recommend? Python? If you haven't learned any programming languages before, then Python's probably a good pick. Python's also recommended because if you run into any problems, there's a lot of people who are writing programs in Python. So try this. So the programming education resources here. There's a couple of good courses. So this one over here, Python Institute, Python Essentials 1, and Python Essentials 2. These are really good courses for learning Python. Okay, so yeah, this lets us know that the bucket region is US East 1. So I guess if you can identify any bucket, you should be able to figure out like which region it's associated with, okay? So East 1, which is North Virginia, log into the AWS Management Console, and then make sure that US East 1 region is selected. Then search for the EC2 service. What's the Nmap results? So Ronan asks about the Nmap results. The Nmap results, it basically said that only port 80 was open. Okay, then search the EC2 service. Click on the service in the EC2 dashboard. In the left-hand menu, select snapshots. So we can't do this via the... We can't take a look at this via the CLI, huh? I guess not. That's unfortunate. Okay, paste the discovered AWS account ID into the field and then hit enter return. After a minute of waiting... So how do we search this? Okay, I'm gonna have to get my own AWS account up and working. I haven't used this account in like 2 or 3 years, but hold on. Let me grab those credentials so that I can log in. Okay, I'm gonna have to Amazon Web Services. I'm gonna have to. So you know the language, but where can I learn it from? Asks Himanshu. Over here, just sign up for. Go to this website. Sign up for the course, and you can learn it over here. Okay, let me. Man. So my other, I'm gonna have to make a new account. All right, let's do it. So Amazon Web Services, I'm gonna have to make an account over here. Create account. Okay, sign up for AWS. Try AWS at no cost for up to 6 months. Okay, great. Let's see. So I'm gonna... Okay. An AWS account name is required. Choose a name for the account. You can change this name in your account. Let's call it HackerFrogs. Okay, making sure that you are secure. This is what you do. We send an account to... Okay. I'm going to have to verify that stuff in my email. Okay, we have to put in the verification code. It's you, your email address has been successfully verified. Great. We need to create a password. I'm gonna have to do this off screen. So everybody, if you want to be serious about your AWS testing, you need to make your own stuff. Falco, I know, you're so disappointed that I'm gonna have to do this stuff off screen. Okay, so Amazon Web Services. I'm just setting this thing up in my password manager. So the username is, what is my username? So everybody here, if you've created an AWS account before, let us know in the chat if you've created an AWS account before. This is actually not something yeah. Okay, so let me do this off screen, just a second. We won't tell. Yeah, I'm not worried about you in particular. I'm worried about other people. Okay. Zenny asks, what do you do for a living? Cybersecurity? I mean, I used to do cybersecurity. I do teaching now. Okay, now I'm logged into AWS. I guess I'm gonna do my free plan. Sure, free plan, please. Contact information. I need to put in my contact information. Oh, I'm gonna need to do this. Passwords aren't real. Nope, they're sure not real. Do I need to put in an actual... I'm pretty sure I'm going to have to put in an actual phone number. Jeez. Okay, and then I need to... This is... This is such an involved process. And then I need to do billing information. Can we not give our billing information? Because I don't want to put my credit card information in here. Oh, we need to put in our credit card information. Oh my gosh. Why am I doing this on stream? All right, well, free credit card info. Funko's so happy. Hold on, everybody. I need to go get my credit card info so that I can put it in and then reveal my credit card number. Just a second, everybody. In the meantime, I can put up some funny videos. How about ooh, I've got my bird videos. Hold on. Okay, everybody, enjoy these birds right here. I'm just gonna finish putting in my credit card info. Just a second. Okay, so I'm gonna have to put in my credit card info. Just a second. I'm gonna mute while I type in my numbers. And they want me to put in my phone number so they can activate my account. Somebody says, Hanzo says, oh no, he hacked the bird. That's very funny. Okay, hold on. man. I hate this. Okay, so I should be able to access the AWS account in just a second. Actually, you know what? I am not super comfortable working inside of the AWS console while I'm doing my live stream. So I think I might skip this. So we might move over to another lab, but you know what? It's super fun. Figuring out that you need to be logged into AWS to do these labs. Let me go ahead and we'll try another lab. It's interesting here. We were able to use a script or something to figure out the AWS account ID over here. Like Linode, maybe. So they was talking about public EBS and RDS snapshots. I guess we'll just do a little bit of reading. So in the response headers, we see that the header is set to, yeah, we did this stuff. As mentioned, the flag in this lab is the AWS account ID associated with the S3 bucket. So I guess we already have it, right? Where did I put it? Here. So this is our flag. Okay, so for an additional challenge, see if you can find the CLI command to list the public EBS snapshots were created in the AWS account. Okay, so I think we're pretty much done. We're pretty much done with this. It's just that we weren't able to do the last step because I didn't want to risk logging into my AWS account from on the live stream. Okay, so let's submit this, and that is the challenge. Okay, so maybe we can start another one. Thank you very much for following Chisunon, thank you. And Panko, what do you got there? Is that soup? Is that soup just for me? Oh, thank you. Thank you, Panko. Let's do the I'm root redeem just for fun.
I'm system root.
Okay, so I mean, this is really good. The fact that we've got all of this cloud stuff that we can. Sorry, I need a little sip of water. So the fact that we can learn all this cloud hacking stuff for free, and it makes this platform really, really nice. Let's go ahead and we'll do one more. So we got Red Team, we got AWS, we got free, and the next thing we're going to do is S3 Enumeration Basics. So let's do it. Okay, we will start the lab, and we will turn on the lab to get started. Okay, so we need a VPN file to access the challenge. So we'll just download it now. So Silva Vasquez, okay. What can you do with cloud hacking? So what can you do with cloud hacking? Well, if we're talking about security stuff, or like what kind of security jobs you can do, there are companies are looking for people who know a lot about cloud hacking stuff, especially like AWS or Azure, depending on what kind of what kind of cloud providers the company is using. Another thing that a lot of people do with cloud hacking is they do web app hacking, because most web apps have cloud services integrated into them. So if we're talking about cloud hacking relevance. So most web apps have cloud integration. This means that, for example, AWS integration. So the app is hosted on AWS infrastructure. So that would be something like EC2 instances. So the other thing is that the files used by the web app could be hosted on S3 buckets. And the web app may use AWS API calls. So this is very relevant, because if you want to do web app enumeration, web app security testing on applications that are integrated into AWS, you need to know how to run your AWS commands to do your security testing. Okay, so let's go back. So the lab is on. We need to download the VPN key. What are API? So API equals application programming interface. This is
I'm system root.
Thank you, Hassie, for redeeming I'm root. Thank you. Okay, so API, application programming interface. This is a way for applications to pass information and operations between each other. If you have a better explanation for what APIs are, I would appreciate it, because APIs they're basically how programs talk to each other. Then they pass information. Okay, so we downloaded. Did we download the key? Yeah. Okay, we did. Sudo OpenVPN. Okay, so we've got access to this new environment now, because we've VPN'd into it. Now we can... Also suitable for a CTF approach. So we've got a URL to enumerate here. What's our scenario? It's your first day on the red team, and you've been tasked with examining a website that's found in a phished employee's bookmarks. Check it out and see where it leads. In scope is the company's infrastructure, including cloud services. So we need to know basic Linux command line knowledge, learning outcomes, familiarity with AWS CLI, basic S3 enumeration, and credential exfiltration. Credential exfiltration, okay? An awareness of how this scenario could have been prevented. So difficulty beginner. Focus red, real world context. So we're talking about S3 buckets. So Amazon S3, Simple Storage Service, is a very popular and the second oldest AWS service that's been used to store files and backups, can be even used to serve websites. This multi-use functionality has led to some to argue that this service would be more secure if it was split into a separate public web hosting and private file storage services. So Santer says it's a set of rules that tells applications what to do, like a mail system of applications. A mail system of applications. I mean, it is how applications talk to each other. So it is like communications. It is a point of communications between different applications. Okay, so where are we? In recent years, AWS has introduced even more visual warnings when customers are making buckets world readable, but still, if this setting is available, people will set it. Misconfigurations or overly permissive settings in S3 have resulted in many data breaches over the years. Okay, so let's check out the website. Let's go ahead and do that. So we've got our... Oh, we're not given any AWS like user profiles or secret keys. That's interesting. So I guess we don't need them for this one. Okay, so let's check it out. And Iqbal, hello, nice to see you here. Okay, so this is the website. I wonder if this website is available from outside. Okay, so we've got a website here, and typically when we try to identify like S3 buckets, I mean, we might be able to see it in the source code. Ah, okay. Okay, so this is the S3 bucket right here. So we can we navigate straight to this? Okay, so we get access denied when we try to access this particular thing. So the S3 bucket is over here. So we get access denied. That's good. And Iqbal, thank you very much for subscribing on YouTube, and thank you very much to CB for subscribing on YouTube. Thank you very much. You're now part of the HackerFrogs crew. Thank you. Okay, so the other thing we could do, now that we know where the bucket is we could do a like an LS search. So S3 LS. And how do we do that? We do it over here. So AWS S3 LS. Wait, what was that command again? Just a second, I've got it in my write-up over here. So something like this, only we need to replace the S3 bucket name. So we got the S3 bucket name over here. So dev.hugelogistics.com. Bad code guy, hello, nice to see you here. What is up? What is up? Okay, so access denied. So we're not able to list the objects in this bucket. Back long stream today. Long stream. I mean, we're going to be finishing off in about 10 or 15 minutes. But yeah, this is about normal for the streams over here. So recursive no sign request. Yeah, so we got access denied for this, but I guess there's supposed to be more. Let me take a look at what the goal is of this one here. So check it out to see where it leads. In scope is the company's infrastructure, including cloud services. So we checked out the website, and then we didn't see anything interesting from a security perspective. The source code, we were able to identify the bucket over here. So it uses an S3 bucket named dev.hugelogistics.com for storing static files. Yeah, we found this. So let's see. We can also try static and style.css. So static. Yeah, I mean, we found this stuff over here. So static doesn't, I don't think it leads anywhere. Ooh, that downloaded something. That it downloaded something. Okay, I guess we can move it into our current directory to see what actually that is. Move downloads. This is, well, I mean, it's empty. We downloaded an empty file. Yeah, what was that download? That's a good question. So when we loaded this page, it downloaded something. So every time we go here, it tries to download something. So let me try the static directory in here. Okay, this says access denied. And I wonder what's going on. So neither of these requests are successful, or both result in access denied messages. Okay, let's try AWS CLI instead. I mean, we've tried this one already. So we tried no sign requests, and we got access denied. Why does it say it's successful here, though? Okay, let me compare this with the command that I did. So we did this. So S3 ls, S3 ls, this thing, right? Let me compare this with the command. So S3 ls, yeah, this is the same. Maybe we shouldn't do recursive. Okay, so it gives us access denied if we try to do recursive. So if we turn on recursive, then it gives us access denied. But if we don't do recursive, then it'll show us the contents. So we got admin, migration files, shared, and static. We also have an index.html. So we could try looking in the other directories then. So we can try admin. Okay, so access denied for admin. What about migration files? So migration files is no good. How about shared? So if there's any directory that's going to be available to us, it's going to be the shared directory. Okay, so we've got this one file in here called hlmigrationproject.zip. So we could probably try downloading this. So it's /shared HL migration project. So here, okay, and that lets us download the file. We'll just move the file into our directory here. And then we'll unzip the file. Migrate secrets.ps1. I wonder if there are any secrets in here. All right, let's take a look. Okay, wow, we've got an access key. So we've got an access key and we've got a secret key. Set up AWS hard-coded credentials. Yeah, this is no good. All right, thank you very much, Niroshi, for subscribing on YouTube. Thank you very much. All right, so, I mean, we could probably assume this configuration here. So, access key, secret key, and this is what, US code, US East 1. So we do AWS configure, and I don't know, we'll call this profile bucket 01. Okay, they want our access key, which is this, and the private key, which is also in here. This is USA East 1. Okay, so from here we can do our enumeration. So AWS STS get caller identity for bucket 1. So which user are we? So we're the PAM test. So user PAM test, we'll remember this in the future. So we can also do AWS S3 API, and we can do list buckets for bucket 01. Okay, we can't do list buckets, but I guess we can take a look at other stuff as well. So I've got my little document that I created here. So S3 buckets. So list buckets didn't work. S3 LS, that might work. Okay, doesn't work. That's fine. So next we will, simple notification service. This is like a subscription service on AWS. So we'll see if we've got any of those on the account. So there's no, well, we can't list those topics. I guess what we want to do next is we want to figure out if we can get the users or the roles. So list users and list roles. Okay, can't list users. I'm assuming we can't list the roles either. No. Okay, so what else can we do? We can try to get our user permissions. So listed attached user policies. So we need a username in this case. So I think PAM test is the name of our user. Iqbal says, what is recursive and why does it get rejected when we add it to the command? So Iqbal, recursive means we're looking in every single directory, and the reason why we got the permission denied is because we don't have permissions with some of those directories. So in this case, if we don't have permissions with some of those directories, it's just going to give us an access denied message. So we can't run recursive. AWS IAM. What was the name of the command? List attached user policies. Okay, and our username is this PAM one, right? PAM test. Okay, we can't do that either. Oh, man. No worries, no worries. If you have any other questions, I'm happy to answer. So, list attached user policies, weren't able to do that. Get user policies, get groups, list roles. I mean, I guess we could also get the APIs from the API gateway command. Okay, so let's try this. So bucket 01. Ah, okay, we can't run this command either. It feels like we can't run any commands. Let's take a look at the walkthrough. How much for? Okay, I'll go for 10 minutes, but then I'm gonna really need to finish for the day. Man, I wish I could just type in the number of minutes instead of using the clicker. Thank you very much for subscribing, Roy Jose. Roy Jose, thank you. Okay, we got 10 minutes on the clock. So AWS, we finished this part. So let's dig in. Attempting to recursively install directories using the recursive switch results in access denied. So we figured this out. Okay. So it seems that both the admin and migration file directories don't allow access, but the static web directory is available, but the files don't seem interesting from a security perspective. I wasn't able to access this one. Okay, the shared directory contains this zip file. So we checked out the zip file, and then we unzipped it, and we found the PS1, the PowerShell script, and it contained the AWS configuration stuff that we were able to steal here. Okay, along with our access key and secret key, we see that the region is set to US East 1. When it comes to setting our keys as our attacker, it's helpful to know which region to use, okay? So the curl command returns the headers only. Yeah, we managed to find this out. So we set the keys with AWS configure. We've done this. So get caller identity. We ran this command to discover that we're the PAM test user. Okay, let's examine again. Oh, okay. So now that we're this user, we can access the admin directory. Okay, let's go back. So we're gonna run AWS profile bucket 01, and we're trying to access the admin directory. Okay, cool. So we have a flag.txt, website transactions report, export. So can we just run ls on this to download the flag? Huh, I guess we can. Oh. Wait, I think we need to run something else on the on this command. What do they want? Okay, this reveals a web transaction export and also the flag. We're unable to download either using our current credentials. Oh, we got access denied on this. Huh. We have more luck with the migration files. Great. So let's try the other directory. Okay, so we got migration secrets.ps1, and we got test export.xml. Indian Sigma, hello, nice to see you here. What is up? What is up? So we got, well, I mean, these are really big files. So these PDF files right here. I mean, I'm pretty sure that this is the file that we want to download. Migrate secrets.ps1. Migrate secrets.ps1. Did that download? It did download. Okay. So we can take a look at this. So is this a different key? Hold on. I should have two PowerShell scripts in here. No, this is like the same, this is the same thing, right? So migration files was one of the directories that we had access to. The other one was shared, I think it was called. Migration project, right. And the migration project had migrate secrets. I think it did. Let me get rid of this first, and then we'll unzip this thing again. Yeah, migrate secrets was part of this. So the migration files, it could be that the test export.xml file also has some secrets in it. So we'll try that. Test export.xml. Hold on. I'm actually not completely sure whether or not we're supposed to be using the ls command to download. I don't think this is what we should be using. Okay, so AWS CLI download file with S3. So download files from the Amazon S3 using the AWS CLI. You would use AWS S3 CP. Okay, so AWS S3 CP. Okay, let's try running that. So it's migrate secrets.ps1 and so the required arguments are required paths. Okay, so how do we provide our path? Download a single file. So AWS S3 CP and then local destination path. Okay, so we just need to include that at the end. Okay, so that downloaded the file. So this is this the same one? Is this the same key? It looks kind of like the same key. So the other file was test something something. Test export.xml. Okay, we'll try downloading that as well. Okay, so that downloaded. And let's see if there's there are passwords in here. Admin at company, Omnicromsoft, and then there's a password in here. That's great. And then we've got other passwords, password Jira, password 654. Yeah. And we've got other access keys for AWS IT. All right, I guess we can... There's just some, just random passwords lying around, huh? All right, let's try doing a new configuration. So this will be bucket 2, I guess. So the access key is this. The secret access is where? This thing over here. Okay, default region name, US East 1. Okay, and then we'll try to access the other thing. Pray right now. Okay. Oh, okay. No worries, Iqbal. Have a good time, and we'll see you next time, hopefully. Okay, so let's try accessing the flag. So we're going to try to access the flag. We're going to copy it over to our current directory, and we're going to use the bucket 2 profile. And that let us download the flag. Okay, so we've finished the exercise. So it's I mean, this was pretty good. This was a pretty nice exercise. Let's go ahead and submit this. Submit flag, bam, and we're done. Great. All right, everybody. This was a lot of fun. Before we go, let's talk about what we're going to be doing next week. So today's Friday, so TGIF, everybody, and we're going to be doing well. There's going to be a lot of fun. We're going to be having a lot of fun in the last week of 2025. So on Monday, I've got a special guest coming on the live stream. She's a member of the DEF CON 2025 CTF winners team, and she's going to be talking with us about how she became a hacker and how she got started with cybersecurity stuff, and she's also going to showcase to us a platform called Standoff 365, which has a lot of really fun stuff. It's a really good cybersecurity education platform, and that's going to be on Monday. On Wednesday, we're going to be testing out a new tool, a relatively new tool on the block called Kaido. So a lot of people have been talking about this tool, and we're going to be testing it out on Wednesday. And on Friday, we're going to be doing more cloud hacking labs, and we're also going to be doing some programming. We're going to be doing Advent of Code, and we're going to be trying to figure out how to finish these coding challenges. It's going to be a lot of fun. But until then, we usually try to raid into some cool people over at infosecstreams.com. This is a website where you can discover other people who do cybersecurity related streams, and Hack the Box is on. I kind of don't believe that Hack the Box is actually on. And Hack the Box is not actually on. Okay, that's fine. Let me check out Twitch to see if any really cool people are on, and then we can try to raid into them. Okay, we got Moohoodles. So Moohoodles is a really great channel who talks a lot about NASA and like space stuff. Let's go ahead and check out what she's doing. If you're not part of the Discord community, we have a Discord. We also have a Reddit. And yeah, let's go ahead and raid into Moohoodles. We'll be back on Monday. We stream every Monday, Wednesday, and Friday. Our schedule is over here. Check out our Reddit or our Discord to keep track of when we're doing our streams. And let's go ahead and set that up. So raid Moohoodles. Okay, so everybody, when you arrive on Moohoodle's channel, I'd really appreciate it if you give this message over here. So it's OS Frog, Hip Hop Hack, OS Frog. So this is for all us people on Twitch. Everybody, thank you very much for coming to today's stream. I very much appreciate it. We did a lot of learning, and I almost gave away my private information by trying to sign up for AWS. But until next time, HackerFrogs out in 5, 4, 3, 2, 1. See you next time.